Is it time? Sup, nerds? Actually, gonna close the door quick. I'll be back in a sec. What is good? We got not as much as usual to talk about today, honestly. It's been surprising to see. There's been like a bit of a news drought recently. Oh yeah, TanStack DB. Fuck, it's really DB day. Forgot about that. TanStack. That's not the TanStack Twitter. Somebody has the Twitter thread breaking it down. That'd be useful so I can add it to the list. Thank you. It was Electric Sequel. Cool. Thank you all for getting us started strong today. We got Wouter throwing over the 34 months of support. Thank you for the mid-sub crisis. Goddamn, yeah, it's been a while. We got Nick here with the Prime 18 months in. We got One Bite SH with the Tier 1, and then Chesk throwing the first Skiff bomb of the day with a 5 bomb. Appreciate that a ton. Thank you all for the support, guys. Always good to see you. Will be a little shorter stream than usual because I forgot I have an event at 5:30, but I'm probably going to leave and get there late, which is fine. But yeah. I wanted to nerd out about a bunch of other random shit, but I don't even know if we're going to have the time to. I really wanted to talk camera stuff because I had committed to not buying a new camera. So I bought a really nice lens. Then the camera I actually wanted came out of nowhere, and I had to pre-order it. So now I spent a lot more money on cameras than I expected to this year. But the Lumix S1 II, which is like possibly the worst named device of all time. The 1-2. But I'm in love. It very much feels built for me. The feature that pushed me over the edge is the dumbest possible thing. There's no way anybody will guess, but I'm curious if you can try. What feature do you think got me to spend $3,300 on this camera over the $1,800 camera I'm currently using? It's going to be a hard one to guess. It's not autofocus. The autofocus is it is slightly better. I have no need for the viewfinder at all. So I'm shooting the S5 2X usually. This guy, which is now finally on sale. That's good to see. This camera is honestly worth like $3,000, so 1,800 or 1,900 is a steal for it. But there's one particular thing that as soon as I saw the S1 II did, I felt like I had to grab it, so I did. No one's done it yet. Button on the left is close. Right direction. I'll give you a hint. Ronan got it. The tally light, the record LED. It will glow red from the front when it's recording. It's stupid how useful that is. It's the only thing I have missed from my Sony. The actual only feature I've missed from my FX30. So it's people asking like, wait, that's not already a feature? It is on film-focused cameras. It's a somewhat arbitrary distinction, but On cameras that are focused on photos, you don't need a front-facing like indication that it's going. And it's also like a lot of people want to turn it off. Like consumer devices, people want to turn the feature off if it comes with it. Professional ones, they want it on and to use it a lot. And it's also particularly only really useful for self-shooting more than anything. If the camera is manned, it becomes less useful again. So it's a niche feature, even if it doesn't sound that way, because all of them have a record light on the back of some form, but not all of them have it on the front. Your $330 phone has a feature where on the side with the high-end lens, it shows you that it is recording. I considered trying to do my own DIY tally light adjacent solution. Not trivial, sadly, as much as I wish it would be. Oh shit, Cody, always good to see you, man. I was talking with some people at an event yesterday about the tech YouTubers that we watch, and I used you as like the example of the type of content I watch and want more of. People who are like actually building things, and rather than just building it live and showing all of the code, trying to break down how they think about it in the decision-making process. And that like in the weeds conversational stuff is what I really want more of on tech YouTube. And yeah, you do it great. Good to see you as always, man. Neo NMG with the 5 bomb. Thank you so much for the support, y'all. Also got Tulays with the sub for 6 months. Appreciate that a ton. Thank you guys all for getting us started strong today. Yeah, this is the main thing I want to drive home with Panasonic stuff, Heath. They're the company that cares the most about what their users actually want by a lot. I could rant about this forever. I've filmed the video like 3 times. It's like why I hate Sony. I just never sat down and edited it and published it. But like Panasonic, or my favorite gag in the most recent like S5 or S12 Chaos. See if I can find it quick. It was forgot the name of the YouTuber. One of the ones I watched. Go to my likes, it'll be in there. Maybe it won't be in there. Huh, I was so sure I did. My watch history. Yeah, that's weird. It would have been between these. Oh, is it coffee? Yeah, it's coffee. Cool. So
theoretically,
one thing, okay, it's playing sound. One thing he did in his review that I absolutely loved is since he got the camera early and he was under embargo, he pulled like the greatest prank I've seen in a minute.
The FX line. So there. How's that for transparency or not conflict of interest, whatever you want to call it. And I decided to put up if the FX3 Mark II a funny experience.
So for context, the Sony equivalent camera line is the FX3. And the FX3 is like a $5,000 camera. $4,000 right now. I would argue the S5 II and 2X compete with this for $2,000. But the new one that Panasonic just put out at $3,200 just slaughters this guy. So what Kofi did, who is, by the way, like a Sony and FX line fanboy, is he took the specs of the new camera before it was announced and released from Lumix, posted them, and said, if these were the specs of the new FX3, how much would you expect it to cost?
On Threads, because that's a good place to do funny experiments. And basically what I wanted to do is I took some of the features of the S12 without saying it's the S12 because I don't want to get sued. And I decided to put up if the FX3 Mark II was actually going to be slated for, I don't know, today. And it was going to have some of these features, the 6K open gate, the less overheating, the better readout, the ability to shoot in 4K 120 frames a second, or something else. I didn't mention every single feature. If it was the FX3 Mark II, how much money would it be, assuming the FX3 was going to be the same price? Because Sony does that. Most people put the range at around $4,500 to $5,000. Some people put $6,000 or $7,000. The S12 is $3,199. So for me, based on the audience reaction, is that if this was a Sony camera,
Yeah. It's actually hilarious that even a Sony fanboy was willing to run that experiment and show that, like, people expect a camera with these specs to be literally 80% more expensive. And yeah, I love Panasonic's current lineup. I am sad that I'll likely be selling one of my 2Xs because I won't need it because I'm going to have the S1 II. I wanted to try and wait for the S1H, but I checked the gap in features between the S1 and the S1H previously, and it didn't seem like I would need the things the H does. But there's like a 50% chance that near the end of the year I'm going to regret my decision. We'll see. Regardless, I have a camera I'm excited about. It's been a bit since I was excited about a new camera. Also, the S6 or the Z6 II is really good and probably better than the Panasonic if you're focused on photos. But if you're focused on video and you can still return it, it might be worth it. But it really depends on if your focus is photography or video. If you want to focus on photos, Nikon still wins. If you want to focus on video, I would probably return it when you still can and get the Panasonic. Good shit. Thank you, WebDev Cody, for the kind words. And yeah, Ras confirming I'm a huge hardcore camera nerd. Yeah, I do this a lot. I do this way too much. Yeah, honestly, and this is the advice I give to so many people, Beryl. The vast majority of people who hit me up asking, like, what camera should they get when they're starting on content? Just use an iPhone. It is like the video cameras on iPhones are so good that there aren't really cameras under $1,000 that are worth it anymore unless you have very specific needs. iPhone video camera is unbelievably good, and it's way easier to get right than a traditional, like, higher end mirrorless camera. Oh, I'm not shooting on the new camera yet. The new camera doesn't come out until the end of the month. I am shooting on a new lens. I got 2 new lenses. One is like $2,400, but I got it for a crazy discount. The problem with that lens is it's a 50 mil. I'm shooting on a 35 in here right now. I tried to reorganize the room a bit to make the 50 fit, and I couldn't do it. No matter what I did, I couldn't make the 50 fit. I do have the video I filmed on that one, though, if you give me a sec. You want to see what that quality looks like. Again, going to be compressed as fuck by stream. I'm going to mute it too because I don't care. But the quality I could get out of that lens was fucking stupid. I wanted this lens to work so badly. It's just too zoomed for this room. Rip. Yeah, desync often is just you need to refresh on Twitch. Yeah, I hadn't fucked with the white balance at all. I just literally put it in to see if I could make it fit. Tracing the thoughts of a large language model. Interesting. This is from March, though, right? Yeah, this was like the breakdown of they don't really get thinking yet and wanted to try and like work with everyone. This is something I actually do want to read later. God, I hope they fix that bug soon. Pocket. Cool. This would just go on Theo Rants, which is already like AV adjacent stuff. What are my sources for news on camera stuff? It's just camera YouTube. I watch enough of it that literally the moment the S5 or the S1 II dropped and I opened YouTube, I had 3 recommendations about it. Interesting hire. I have seen TanStack DB. It's on the list of things to cover today. Yeah, I did see this too, that people wanted it in the UI. Yeah, this is a very good point too, Ras. My rule for like finding success on YouTube, so I saw somebody else ask about that. Make the videos you would have watched. You have to be like super honest with yourself with that. Like, if this video had come up on your feed, would you have clicked on it and watched it? And would you have enjoyed it? Like, would you watch the full thing through and enjoy it enough to watch other videos by that creator? If so, then it's a good video. And if not, fix it or throw it away. Those are your options. Consistency doesn't even matter that much. Like, consistency helps just because you get the reps in more so than like the YouTube algorithm likes when you upload a bunch. The key is to just make like, or have a high floor. Like, every video you post should be something that you honestly would have watched so that people watch it. And as long as that continues, you'll be fine. It might take some time, but if every video you post is like genuinely watchable, then you'll get there. But part of watchability isn't just like the video was recorded well or the topic was good. It's the packaging as well, the titles especially. Things like the audio quality matters a lot, the flow of the video, the delivery of the promise of the packaging. It's all these pieces, and you have to be like really introspective in order to get good at it. But as long as you're thinking a lot about what you're watching, why you're watching it, and if you would have watched these other things, then you're probably going to figure it out. And yeah, audio is way more important than video, 100%, which is kind of crazy. I got popular because my voice sucks. Like, I'm not saying this, I want sympathy or some shit. I'm just like, I'm an audio engineer. I look at the readouts in actual like audio software. I know that my voice falls in an unpleasant range. And that's fine. It is what it is because I make compelling enough content and I do good enough processing of the audio that it's listenable. But yeah, I am aware of my shortcomings. Would I recommend Logic over Reaper? I'm an FL Studio guy, so don't ask for my take on DAWs because I'm probably wrong. Yes, I know that Keith doesn't work at Brave. He's just a fanboy. Thank you to all the people who just resubbed. Kevin, throw in the tier 3 for 3 years. Fucking legend out here. Thank you so much. The Motorola squad. I used to be the biggest Motorola fanboy. It's been one of the saddest fall-offs that I've ever seen. I was into Motorola, especially during the early Android era and when Google acquired them. RIP. And then Dan throwing the 13 months. Always good to see you, man. Hope all is good. Think I got you 2 days. Regardless, appreciate you a ton. And then Sterling with the 23 months. About to hit that 2-year mark. We need to start filming. We got too much to talk about. I nerded out about cameras for long enough. Let's do the offset marker. We'll aim for 29. Dan, I am currently in the public, which means it is absolutely FL Studio. Kellogg sued them for the Fruity Loops name, if you recall. So it is not Fruity Loops. It is FL Studio. Ah. Make sure I have this for the TanStack DB vid. Okay, good, I do. I have the GitHub repo. I'll throw that in as well. Close, close, close. Get that here. And damn right I watch Bringus. Is that really a question? Yeah, I record at 4K, so we're in a good spot. Oh, that reminds me. I need to make sure I have room on my drive so I don't run out of space. I've done that before, and good thing I checked. We're low. So let's quickly dump some old things. Almost certain all of these are old enough I can safely destroy them. Looking for large things. That's done. Those are done. Those are tiny. Oh no, that's the wrong thing. That's why. Okay, that makes more sense. Okay, I'm just gonna delete a bunch of shit and hope that it's all fine to delete. Delete all. Hop over the recycle bin and empty. Cool, I just freed up 2 terabytes of space. Nice. Managing large amounts of video content is a wild journey. Yeah, I have 2 4 terabyte SSDs in my machine that I use for streaming. One is my like OS drive, one is my write drive for the things I'm actually recording live. And I just slowly fill it up until it gets close, and then I offload. I also have a NAS, which is where all of the chunked topics go. And then I put those on my, or as soon as I put those on my NAS, they automatically sync with Dropbox, and then FaZe can download them in order to get the edits done. But yeah, I can't record straight to the NAS. I theoretically could, but I don't want to deal with yet another network I/O boundary if I can avoid it. Having it on the machine is nice for the chopping process. Don't make me start on capture cards. I will literally rant for like 6 hours, and I need to film. It's one of the Synologies. It's the last gen 8 bay with a 10 gig Ethernet card on it. They sent it to me because I was going to do a video about using it for dev stuff, and then it absolutely sucked for dev stuff, but it's been a life changer for everything else. I'm going to do Expedition 33 soon. I have to finish Persona 3 Persona 3 Reload. I'm like very close to the end of that. Then I'm going to probably start Metaphor. I might do Expedition 33 instead, but I'm leaning towards doing Metaphor. Have to decide still. Actually building a sync engine. I got 2 burned on No Man's Sky when it dropped. And yeah, we'll be talking about this. I'm not sure how in the weeds we'll go, but we'll definitely talk about the convex stuff. We need to start the neon stuff first, though. Let's do that. Marker neon acquisition. Cool. It feels like there's a new database startup every week. From PlanetScale to Terso to Neon to Convex, there are just so many different options. At least there were. But recently it feels like we're ending up with less options, not more. From PlanetScale killing the free tier and focusing entirely on enterprise customers, from Fauna shutting down, and now Neon being acquired. Yes, Neon, everyone's favorite Postgres database provider, has now been acquired and is part of Databricks. This is a fascinating acquisition, and there's a lot to talk about with it. I'm very excited to go in depth on what this means, both for Neon users and the Neon company, more importantly, for the whole database ecosystem and the innovation that we've been seeing in database platforms over the last decade or so. There's a lot of context that's important to understand for what's going on here. And if you're trying to decide which database to use, I think these things will be useful as you figure out the ecosystem and where things are at. That said, none of the companies we're talking about that said, none of these companies are paying me to make this video, and someone's got to make the... That all said, none of these companies are paying for this video, and someone has to pay my editor. So quick word from today's sponsor, then we'll dive right in. Neon and Databricks. Before we dive too deep into the post, I should give a little bit more context on who these players are. Neon and the state of DBs. Neon is an interesting company. Neon wanted to rethink Postgres. If you're not familiar with Neon, the TLDR is serverless Postgres. The longer form version is that the founder of SingleStore, who you might know because they previously sponsored one of my tutorials. SingleStore is an interesting database platform really focused on SingleStore is an interesting database platform really focused on performant enterprise DB use cases, having a single DB that can do everything from like vector database lookups to giant MongoDB like API compliance stuff. Retake on that. SingleStore is an interesting product. It's very expensive and hard to set up, but if you need the features it has, it seems like it makes a lot of sense. That said, for use in things like tutorials and small projects, 90 cents an hour or like $50+ a month is not an easy sell for a lot of people. So interesting role. You can also self-host, which is cool, but yeah. The reason I bring up SingleStore has very little to do with them though, is that their CEO left and started Neon. He started Neon because SingleStore was a little more MySQL-y and had focused entirely on enterprise. And he wanted to focus more on this new era of small to medium stage companies, side projects, all the things that SingleStore realistically wasn't great for, because he saw a growing market in these smaller teams building things. And there's an important detail here that I think we need to understand. I hope I don't have to go too in depth here. We'll see how y'all feel when I say it. Postgres kind of sucks for serverless. I know, bold statement, but the issue with Postgres is connections. The connection pooling, or the connection, how to put it? You're effectively forced to manage individual connections to the Postgres instance, and those take resources. When you're using serverless environments like Lambda, like Vercel, like Netlify, even like Cloudflare, the connections you form are ephemeral. You make a connection, you complete the request the user has, and then you close the connection. And that means that at any given time, the number of connections you have formed is roughly the number of things you have people doing at that moment. So if you have 10 users making a request at the same time, you have 10 connections. If one user is making 10 requests at the same time, they're causing 10 connections. So if your database is limited on the number of connections it can have, good luck, have fun. I learned about this real early when I was trying to do one of my first Vercel deployments alongside Heroku on the free skier on there. I learned about this the hard way back when I was trying to use the free tier on Heroku alongside Vercel. And just in my own testing, I was able to hit connection pool limits and watch my stuff plummet. And my options were and the option that was recommended to me was to spend like $400 a month on their private connection pooling solution that also would have been relatively limited. This has caused problems for a lot of people betting on serverless, including companies like Supabase, because they've had to build their own connection pooling layer that still has relatively low ceilings for how many connections can be formed on a given Postgres instance. That results in high throughput serverless workloads not working great in a Postgres environment. And to be clear, MySQL doesn't magically solve this. However, a lot more work has gone into pooling and separation in MySQL because as an architecture, the pieces are a lot more separated than in Postgres, where everything's kind of tightly tied together. There's also companies like PlanetScale that provide an HTTP layer. So instead of querying my DB via a native connection to it, I can send a post request to an HTTP endpoint that handles all the pooling and connection management for you. Works really well for serverless. I found PlanetScale to be a phenomenal solution for that reason. So Neon wanted to solve this as well. Not just because serverless is hard, but there was a lot of DX problems that using traditional Postgres could cause you. One of the biggest ones that I think Neon actually got really, really right was preview environments. Preview environments are one of those things that, like, once you have it, you can't really go back. If I go to any of the current pull requests on T3 chat, I can hop over to this import chunking PR where Mark fixed the imports. And I can click this visit preview button. And this will bring me to a link that is a preview environment. I have to enter a little password for it. And now that we're in, we have a fully working preview environment that has everything we need to test the changes that were just made. You'll see it's a URL specific to our project. The point here being, it's really useful as part of our review process to actually test the thing the person made without having to download the whole project, have to switch to that branch, install the dependencies, run the dev command, and then go play with it. Now you can just click visit preview. And once you have a workflow like that, it's really, really hard to leave it behind. And that's a huge part of what Neon wanted to figure out, is those types of modern DX expectations that traditional Postgres made very difficult to do. Because if you had a branch that added something to your database schema, you can't connect it to your traditional staging environment. You probably have to go spin up a new database directly. And each individual DB is quite expensive due to, again, everything being so tightly tied in Postgres. So one of the things Neon focused a lot on was branching and making any individual DB deployment as cheap as possible. You might be curious how they did that. The answer is interesting. This is their open source Neon database. Serverless Postgres, as it says right there. Don't know how much you guys know about Postgres, but it was not written in Rust. Neon is a full rewrite of Postgres, focused on all of these things, with the goal of, to the best of its ability, making something that is Postgres compatible while also being much, much easier to use in these new environments and ways. It's an open source alternative to Aurora Postgres, which is also AWS, believe it or not, has seen a lot of the same problems and tried to build their own solutions on the AWS side. Neon's an open source alternative that also has their own cloud. And that cloud has historically been quite cheap. The free plan gives you 10 projects, half a gig of storage, and then a ton of compute hours. For $20 a month, you get 100 projects, 10 gigs of storage, and auto-scaling up when your databases need more throughput. It made a lot of sense as a product. Their uptime was horrifying. I think it's gotten better since. I don't care to check because they don't report their uptime in ways that I consider respectable. But they built something legitimate with the goal of making Postgres work better in these modern environments. They also scaled up really aggressively. This was the biggest concern I had with Neon from when I first started talking with the team and the founder. Actually, before I show that, I'm going to drop some numbers and have you guys guess some things. I want to find... That's the right Nikita, right? No, it's not. It's Nikita Neon. Cool. Trying to find he had shared the number of databases being created at some point. Cool. They're deploying 3,000 DBs daily. They have 750,000 of databases under their management right now. How many employees do you think they have? For reference, T3 Chat does a few 100,000 messages a day, and it's 2 employees, Mark and me. And if I recall, Planet Scale has under 40 employees. Might even be smaller than that. So here are chat's guesses. 5, 3, 10, less than 50, 20, 25, 40, 3,000. mostly numbers under 50. They had 130 fucking employees. 130 people. You understand how insane that is. I remember when they were still really early and they had like 90 employees while having like less than a fifth the traffic of Planet Scale, which had like 40. It's massive, massive overhiring, in my opinion. So, napkin math, even if we assume a lower salary, because they're obviously not all eng, we'll assume 90,000 base salary times 130 people. Just salaries alone, that's 11.7 million a year just paying your employees. That's kind of insane. If you come from the single store enterprise world, makes sense to have a ton of employees, but in modern startups, it doesn't at all. And to contrast with Planet Scale, they got roasted for doing layoffs a while back. I want to find the post. Kind of crazy. This was over a year ago. Yeah, I thought there might be direct numbers in here. There aren't, but when Planet Scale killed the free tier, the goal was to make the business profitable so it will be there forever. So you don't have to worry about your database running out of funding and going out of business, like Fauna just did a few weeks ago. The goal was to make the database something you knew would still be there next year. So big businesses that were iffy on making this type of bet would be able to do so more reliably and with more trust. So again, getting your database company profitable is hard, and doing that with that large number of employees is nearly impossible. So let's look at the current database startups that we have. I'm going to start with Planet Scale because they're the one I'm the most familiar with and like know the most about. Interesting characteristics about Planet Scale are individual DBs are expensive, scales incredibly well, best performing option, even considering AWS's. Especially now that Planet Scale has Metal, they have one of the best products on the market. It is going to be really hard to compete with them if you're looking for something to set and forget and never need to touch again. Next, we could look at something like Terso. Terso has very different characteristics. If you're not familiar, Terso is a SQLite database platform. And they are hilariously cheap. Their free tier lets you have 500 databases. The reason for that is individual DBs are hilariously cheap because they store the SQLite database as like cold storage in S3 and recover it when a request is made. A DB that's doing no traffic costs them zero. It is effectively free. That allows them to do crazy things in terms of the generosity of the number of databases that you can have set up. But the scale's weak. I was able to make it buckle relatively easily just under some basic tests. And reliability is not there. Of all the database companies, Terso's had some of the most embarrassing flubs. They recently started defaulting users to their new AWS deployment instead of their Fly deployment. And they lost all the data on the AWS deployment a few weeks in. So everyone who had clicked the next button 3 times and just went with the defaults lost all their data. Prior to that, they had a bug with the restoration of the S3 file where they could restore the wrong one on a request, and certain users were getting access to other people's data because when they tried connecting to their DB, someone else's database was restored on the node. So if you're really trying to make something reliable, they're not a realistic option, sadly. So we have, if we were to like make a range here, we have Terso on like the beginner side project side, Planet Scale at the enterprise, like ready to go for scalability side. Neon was trying really hard to be an in-between here. Neon wanted individual or DBs to be relatively cheap, enough for branching. Branching being if you make schema changes, you can have a branch with the changes, and then once you've decided it's good after your pull request is done and all that, you can merge the branches changes into the main deployment. Scales fine. Reliability is improving. As far as I know, they haven't had massive data loss instances or data exposure stuff like Terso has, but they had a lot of downtime over their first 2 years, and it's gotten better, but it's still, from what I've heard, not great. So Neon's this weird in-between of these. If we were to think about this a little differently, instead of just thinking of this as like, how do they differ technically? Let's instead think about how much money it costs to run them and how much money they could potentially make. So if a given planet scale database costs the minimum $20 a month to run, they need to make serious money on these users. So if it's $20 a month, they can charge 30. With the new metal stuff, they can charge much, much higher amounts, like literally like 500 plus a month with no issue, because they are so far ahead of the competition and can do things that like you normally spend thousands for. They can get away with that. No user on Planet Scale is free anymore. So every user is paying them. So anytime somebody spins up a database that costs money, Planet Scale charges them more than it costs them. So every new user is guaranteeing they make some money. Things are a little different for Neon. I have no idea what their cost basis looks like. I could try running their DB stuff and like get a gut feel myself, but I haven't had a chance to do that just yet. But if we assume it's like even 10x or 100x cheaper, it's 20 cents a month per DB that someone's running on Neon. The average Neon customer pays them $0 a month. So every time a new customer spins something up on Neon, it's purely at cost for them. If you combine that with the amount of money they are spending on employees and marketing and all the other things they're doing, their costs are probably absurd. Terso is similarly hilariously cheap, probably even less. I'll say it's like 5 cents a month for them to run things. But I am the only person I know that's paying for Terso right now. I just don't know a lot of people who are doing it, and they've been experimenting a lot with their tiers to try and make money on a cheaper tier. If I've learned anything about this with products like Upload Thing, you will never make a successful business charging devs $10 a month. You need to charge a lot more than that in order to make your thing profitable. So even though Planet Scale has the highest cost per user, they are by far the most profitable, have the best margins, and the best long-term upside. But there's something that buffers this a lot. Fundraising. Fun fact about Planet Scale's history. The CEO of Planet Scale, Sam Lambert, was actually a Sequoia partner. Sequoia is a huge investment firm, clearly was part of how he got involved. He was an investor in Planet Scale before he joined and then became CEO. Sam deeply understands the fundraising world. And he saw back in 2023 that the likelihood they could raise another huge round at Planet Scale was low. So these are all entirely fake numbers. I just want to give you guys an idea. If Planet Scale raised $10 million on a, I don't know, 80 million valuation, They now have 10 million in the bank that they could spend and use to eat costs, justify free tier, do marketing, sales, all those things. And they gave up an eighth of the company in the process. What happens if they run out? Once that 10 million hits 1 million and you see that your runway is down to just a few months, you're going to be out of money in 6 months or so. You could raise more money. But if your profit at this point was, I don't know, 800K a year, and now your profit's 1.2 mil a year, and you got that gap over 2 to 3 years, that's not a whole lot of growth, and your costs are still absurd. Who is going to invest more money knowing that you're desperate and you're not increasing your revenue very quickly? Like, it wouldn't make sense to invest. And that would mean they have to do a thing called a down round. Down rounds are terrifying. When you get more money on a lower valuation, your company is now worth less. And this 10 million, especially if it was on a safe or some type of like MFN equity, this is no longer an eighth of your company. It's now a sixth of your company. And you just sold another sixth. So you went from giving up an eighth of your company to giving up a third of it very quickly. Sam saw the writing on the wall. He knew that since he raised on a really high valuation, the likelihood of doing another higher one was low. And the reason like VCs invest on these high valuations is they think eventually the company can sell or IPO for a much bigger one. If you invest a bunch of money at 80 mil and the company goes and IPOs and is worth $1 billion, you just more than 10x'd the amount of money that it put in. So if you put in this 10 mil at 80, and then they end up being worth 800,000 or 800 million, so if you put in this 10 mil at the 80 mil val and they end up being worth 800 mil or $1 billion, you just turn 10 mil into 100 mil. That's why these companies are investing. But if it doesn't look like there's a chance of this being worth $1 billion in the future, you can't really raise money at that point. So if your costs are going up and your revenue isn't going up fast enough to compete, and you don't see a path to raise more money, you have to look for other options. And the option PlanetScale looked for and found was that they decided they would and the option that PlanetScale found and chose was to make themselves profitable. If they can't raise their revenue fast enough and they don't want to raise more money, what if we reduce costs instead? If you have the 3 metrics, which are money in the bank, money that you're making, revenue, and costs, you can't increase money in the banks, you can't raise more. Making more money costs more money. So how about you reduce costs? That was the choice that they made that resulted in them being able to not only survive, but thrive. They're doing better than they've ever done. They're able to build things they couldn't have built before. And the results, awesome product that's super reliable, being used by everybody from T3 chat to Square and Cash app. It's kind of crazy how much stuff, both data and now money, flows through PlanetScale. And Sam's at the point where he is like anti-fundraising. So why am I talking about all of this here? Because Neon didn't just fundraise. Well, if we think about these 3 things, which are money in bank, costs, and revenue, and we think about where Neon's at for all of these, well, I'll change the order a little bit to make this flow better. Costs, as we've discussed, aren't great. The engineering side in particular and the employee side is absurd. I'd be surprised if they were spending less than 12 million a year on payroll alone. Revenue, I can't imagine it's particularly high. As we saw in their pricing page, the only options that are under the fold here are $0 a month and $19 a month. And then they have the scale, which is 70 a month, and the 700 a month for business. But they're not printing. I know that much. There's almost no way Neon is making a ton of money right now, especially because of the thing that's caused their recent surge. I want to find, there was a chart when I was first looking this up. due to all of the AI agents being able to spin up databases in the AI app builders like Replit, or due to the recent surge in AI app builders, things like V0, Lovable, Bolt, Replit, etc., many of them use Neon as the default database because the free tier is generous. They could spin up a bunch of databases using Postgres. It made a lot of sense for them, which has caused a massive surge in the number of these databases that are being opened. How many of those people that are generating these apps do you think end up becoming paying customers for Neon? My guess is it's a very small number. They have 4x more databases created by CodeGen than by humans as of February. That ratio is getting worse, not better. So, costs going up massively. Revenue, probably not moving a whole lot. Maybe it's bumped a little because they're getting companies like Replit to pay them for some amount of the allocation. Money in bank, almost certainly going down fast. I'm trying to find their last raise. Oh shit. Lana Lux with the raid. Thank you so much, Lana. I really appreciate you. One of my favorite people in the game dev world. For those who don't know me, I'm Theo. I'm a software dev. Built a bunch of things. The one I'm mostly known for nowadays is T3 Chat. Best AI chat I've ever made. Really proud of it. Spend a lot of my time filming YouTube videos live on Twitch with all you guys so we can cover all the fun things that happen any given week. I'm live every Wednesday just to talk about whatever happened over the last week. For everybody who's here for me, Lana is one of the few who actually devs constantly on Twitch. She's been building games on Twitch for a while. Definitely worth giving her a follow if you haven't yet. If you want to be deep in the weeds and see someone who's actually building things live, she's great. One of my favorite people to just like idle in and like watch. She's great. Highly recommend lurking that channel if you haven't yet. Yeah, I know I need to look more into space-time. For those of y'all who just tuned in, we're talking about a recent acquisition that happened with Neon, a Postgres database company that was just acquired by Databricks unexpectedly. And I'm trying to go in the weeds on why this would happen, what their cost profile looks like, and all these other details, because I'm in the startup world. It's fun stuff for me. Yeah. Okay, here's what I was looking for. Neon has so far raised $129.6 million. That is insane. That means they've either given up over half the company or their valuation is something crazy like $1 billion, which I don't see how they could ever be $1 billion company personally. So, yeah. It's kind of absurdly, I don't want to say overvalued because I don't know what the actual valuation was. The 19 bill number here, that's Databricks, not them. But 129.6 million raised is absurd. And that's the only reason they could justify the 130 employees that they had. This is my problem with Neon, is it always felt like they were operating 2 tiers past where they were. Like they'd be competing in the startup space, but hiring as though they were an enterprise company. And it felt like like they were building a castle out of like cards that was just waiting to collapse. And I was starting to think it would. And my guess is that Nikita went to go raise more because he went to all these VCs like, hey, we're the database that all these AI companies are using. We need more money. They're like, oh, cool. New business, probably what, 100 mil valuation? They're like, oh no, we're raising on a 2 billion valuation. To which the VCs looked at their numbers, looked at their costs, looked at Nikita and said, what the fuck are you talking about? So if you can't raise without giving up a ton of your business or doing a down round, which when you've already raised 130 million, good luck. The revenue's not growing fast enough. Their costs are going up like mad. What are your remaining options? That's when acquisition happens. So the thing that Neon had that made them valuable was one of the easiest ways to deploy lots of the thing Neon had that makes them valuable is the ability to, at early to mid stage, deploy tons of Postgres databases for relatively cheap. Databricks is a very different company. Databricks, how does one describe Databricks? They're now the data intelligence platform. Cool. That is slightly better than their homepage. They're a unified open analytics platform for building, deploying, sharing, and maintaining enterprise-grade data analytics and AI solutions at scale. Their data intelligence platform integrates with cloud storage and security in your cloud account and manages and deploys cloud infra for you. So it lets you point things at random databases so you could do data analytics, warehousing, all the things that your data teams need. They've been around for a while. They make a ton of money. I have a few friends that work at Databricks. They've never paid me or even reached out, but they're a legit like enterprise-y data analytics company. Databricks doesn't host databases, at least in the traditional sense. Like they're not the thing you write to when a user signs into your site. They're a company that helps you build the analytics platform around your existing database. But they're also very clearly trying to get into AI. As you can tell by the nonsensical homepage. Your data, your AI, your future. Yeah? Yeah, you get the point. Databricks is a very enterprisey business that's trying to figure out the AI thing. They don't have a database platform in the traditional sense. They have a whole lot of money, a whole lot of enterprise customers, not a whole lot of way to grow in the small to medium-sized stuff. Databricks has a whole lot of growth in the small to medium size, no money, and no enterprise customers. It's actually kind of a match made in heaven in that sense. Databricks now has a way to introduce their offerings to smaller companies as they start to scale, and Neon now has a way to not go out of business. Did I say at some point before I said Neon I sent Databricks when I meant to say Neon? I'm sorry if that was confusing. I don't remember when. Not going to re-record. You guys are watching the videos as I record them live. Sorry for the flubs. The core point being Neon needed the stability of enterprise and money. Databricks wanted more early stage stuff and more AI focused everything. Phase, don't worry about fixing it in post. You can leave the flub in as long as you leave me saying it was a flub in. So let's look at the actual post that Databricks put out. We're excited to announce that we've agreed to acquire Neon, a developer-first serverless Postgres company. Actually, okay, one more tangent, just because I have thoughts on Nikita as an individual, and I think this will help showcase what I'm talking about. We're excited to announce that we have agreed to acquire Neon. It's clearly what's happening. They have a ton of money. They're spending the money and spending some equity in order to buy the Neon business. Neon and Databricks. This is the Databricks, or this is the post on the Neon site. Today, we are thrilled to announce that Neon will be joining forces with Databricks. The comms I've seen from Nikita have mostly avoided the word acquisition. At the very least, it's multiple sentences in. The posts I saw on Twitter and whatnot were very much Neon is partnering with Databricks. Because I think Nikita doesn't, how do I put it? The phrasing I have used that's a little rude, but it's the best I have for this is what I call cosplaying startup or cosplaying CEO. It's when someone really wants to run a big company, they see what all these other big companies do, and they copy those details instead of the actual like thing. What's the old story of the like helicopters would drop resources so the native people started doing weird things thinking that it would cause the helicopters to drop more stuff? What's it called? I don't know. Beta.t3.chat. Cargo cult, yeah. The better terminology would probably be cargo cult. I always forget the word. The concept is people see the outward action someone does. Like for my YouTube channel, you see the goofy thumbnails and titles, and you assume that's why I'm successful. So you copy those parts, but you don't actually see where those came from and why I do them. You just see the thing, so you copy it. Successful businesses hire a lot of people. So if you want to be successful, you should hire a lot of people, right? No, not at all. The reason successful businesses hire a lot of people is because successful businesses have a lot of problems and they begrudgingly have to hire to solve them. These are common things I see in founders and startups. And when I invest in an early stage company, I often make them promise that they will not more than double in size by the end of that year. I actually just made this promise with 2 different startups I was investing in. I made them guarantee to me that they would have less than 10 employees by the end of the year, and they wouldn't go spend this money over hiring and destroying themselves in the process. Neon did not do that. Neon was very much built as almost like a sequel to Single Store, the big enterprise database company. And as a result, I think Nikita might feel a bit of shame that he went the acquisition route. It is kind of playing it out a little differently as a result. I'm sure this is not what he wanted to do, but it was the best path to preserve as much of the business and the money and the investors' interests as possible. Let's go back to the official post from Databricks. Neon's team engineered a new database architecture that offers speed, elastic scaling, branching, and forking. Capabilities make Neon great for devs and also great for agents. Today, we'll deliver an open, serverless database foundation for developers and AI agents. Hi. Yada, yada, yada. Oh, look, that same 4XM we were talking about earlier is in here too. AI agents are creating 4 times more databases than humans on Neon. Yeah. This paragraph kind of says it all. My face covering it a bit. Cool. If you think of AI agents as your own massive team of high-speed junior devs, potentially mentored by senior devs, then it's not surprising that the same capabilities that Neon team focused on make Neon great for devs and also make them for... read on this. If you think of AI agents as your own massive team of high-speed junior devs, potentially being mentored by seniors, then it's not that surprising the same capabilities that the Neon team was focused on that made it great for those junior devs also make it great for these AI agents. That is Databricks' whole vision here. Previously, they were fully focused on enterprise because that's where the money is. But the thing that is changing right now is that what was previously stereotyped as like junior, beginner, small stage stuff is happening more and more at these big businesses. And those small things are becoming more and more profitable, thereby are more and more willing to spend on products like Databricks. So if you want a company like Microsoft to use Databricks and you are struggling to get the big Microsoft products to use it, Microsoft now has a bunch of small teams vibe coding their way through random stuff that they're dogfooding and testing out. If one of those happened to use Neon and then it does well, and then they need analytics on it, Databricks would be a way now to get this one small team at this big company to start using their new product. And now Databricks can get in at these places that traditionally this would have been how you get into a small startup. Big companies are becoming a bunch of small startups within them. This is more and more the trend. Facebook's been on top of this forever now, but we're seeing more businesses do the same thing, where there are small vertical slices that build their whole product top to bottom. And those teams are getting smaller and faster than ever using these AI tools. If Databricks wants to survive this new wave of small to medium enterprises, this is a great path there. And they knew their existing product made no sense for it. All of a sudden, this change is happening. And this is kind of a hedged bet, where if these smaller teams and smaller projects and junior engineers that are making these decisions start to make real money at these big businesses, Databricks now has a way to keep them in family and pull more people in as a result. I've seen this a few times now where effectively like different businesses built a thing focused on a specific segment of the market that accidentally made a really good thing for AI. Some of my favorite examples of this are Convex, who admittedly is a sponsor, not of this video, but they sponsor random videos on the channel. Cloudflare. And now, of course, Neon. Convex does this well because Convex puts everything inside of a single directory in your code base. They are truly infrastructure as code. The schema for the T3 chat rewrite, this is the whole thing, is just here as a file. If you were to get this code base and you wanted to connect Convex, you don't need access to our deployment because there are no switches we hit in their dashboard or anything. You literally just run npm run dev. It asks you to authenticate with Convex, if you haven't yet, and then it asks which project is part of it or if you want to make a new one. And then it provisions the whole thing. The magic there is that AI is really bad at navigating a dashboard like AWS and remembering which switches are hit where and what state things are in. AI is really good at taking a bunch of text and making changes to it. So if you can actually properly do the thing we wish Terraform did, where your entire deployment and all of its characteristics just live in a directory of text files, ideally source code that's type safe like it is with this. This helps a lot with me as a dev not making mistakes as I iterate, but it helps even more for AI because now it has a type system enforcing all of the behaviors it's doing, and deployment is just a command it runs rather than a bunch of steps it has to get right. Even with Terraform, things are not competent in that side. You still have to spend a lot of time doing weird bullshit and hooking things together. Convex is kind of the perfect backend for AI because everything just is a directory like this. And stuff like triggering updates on client is comically less work too due to their sync engine. Convex, by building a really good, simple thing for front-end devs that didn't want to do the inner workings of backend, they built the perfect backend for AI app builders. Cloudflare built the perfect infrastructure for doing inference for generating LLM responses. Cloudflare's workers are a glorified switch statement. That's what I've called them forever. That's both why they're so magically cheap and spin up so quick, and it's also why they suck at things like SSR because the amount of CPU on a given worker is really low. Cloudflare workers are isolated in like the V8 runtime, so it's similar to how tabs are isolated in your browser to an extent, which means that when one tab is waiting for some data to come in, other tabs now have more CPU. As a result, Cloudflare doesn't charge you based on how long a request took. It charges you based on how much CPU did you use during that request. So if I am generating an AI response from a slower model like DeepSeek, and it takes 70 seconds to generate, if I do that on Vercel, I'm charged for 70 seconds. If I do it on Cloudflare, I'm charged for like 40 nanoseconds because it's spending most of the time waiting for the next chunk to come in from the provider. They built the perfect infra for infinitely scalable AI inference. Vercel's catching up with the stuff they're doing with fluid compute, but you're still being built on a wall clock in the end. If I have a request that takes 70 seconds, the Lambda's up for 70 seconds, I can stuff another 100 requests in that 70-second window, but it's not going to get close to the 40 nanoseconds that I'm charged for on Cloudflare due to the difference in their compute model. That compute model made workers garbage for so many things. They're not running nodes. You lose access to everything from like file system to connection like management. They didn't even have async local storage until recently. And I don't even know how that implementation works. I'm almost scared to figure it out. They're too slow to do things like SSR well. So you ideally want to generate the assets ahead of time and just use Cloudflare as like a redirect, again, switch statement for getting data to and from things. But the price is hilariously cheap. Neon is similar in these ways where they built the thing focused on like junior devs and simple workloads that also is very beneficial for AI. If an AI has to sit and wait for 5 to 15 minutes for your Postgres instance to spin up, you have a terrible experience. Being able to spin up a database in seconds is cool as a junior getting started trying out the platform. It's way cooler as an AI agent that needs to spin it up in order to work on a problem or do something like a preview environment so I can see the changes the AI made. All three of these companies spent years building a thing that was useful to an extent, but relatively niche in how valuable it could be. And they were more parts of an ecosystem rather than a bigger solution that are now 10x more valuable and way bigger than they ever could have been because AI happens to work really well with the mental models that these tools recommended. That's just a thing I've been noticing is there's a lot of these tools that made some sense before that make way more sense due to AI. And Neon is one of them. But their costs are just beyond unrealistic. So there isn't really a path for them to raise a whole bunch of money and keep growing. They're just going to keep losing money. But if Databricks wants to play in this space, because Databricks built a product that isn't ready for the AI space, what they built doesn't have the weird benefits that these things do. So they're acquiring one of those weird benefits. They're acquiring one of the platforms that benefits greatly from the AI wave in order to have some of that benefit for themselves. Also, Phase, if you can cut this to when I was talking about the like SSR on workers bit, that'd be really cool. Find one of the spots there to do it. Therbra dropped in chat that Cloudflare SSR sucked really hard for them. It was 3-second time to first byte. That means when the user makes a request, it took 3 seconds for them to start seeing HTML because they were generating the HTML on the worker. Some amount of that is because the worker isn't necessarily close enough to the DB, so if it's fetching data, it's going to be slower. But a lot of it's just that the CPUs and the amount of like throughput you're getting on the CPU on a worker is relatively low. This is focused on running simple JavaScript scripts. So yeah, it's not the best thing for generating web pages, but it's phenomenal for taking a request, sending it somewhere else with an API key, and streaming the result back to the user. So checks and balances with all of these things. I think I covered everything I wanted to in this one. The state of databases is fascinating right now. I don't have direct recommendations. I hope this helps you better understand where things are at, what the benefits and negatives of each of these platforms are, and hopefully you can avoid a disaster similar to Fauna. And if we look at this as Neon protecting their users and their data, knowing that raising more money was unrealistic and profitability was too, awesome. But if we look at this as the end of database startups, things get a little bit scarier. I loved the 2020s surge of these database providers trying to rethink how we operated with our data and how we thought about SQL. I think that era might be over, and I think the acquisition of Neon shows just how over it is. Let me know what you think. Am I overreacting here, or is there really a change going on in this industry? Curious how y'all feel. And until next time, keep querying. Cool. I'm not gonna lie, I wasn't sure how valuable I can make that video. I kind of fucking killed it. I think that's one of like the more valuable in the weeds videos I've done in a minute, where like if you don't care about the startup shit or whatever, cool, but I don't think a lot of engineers know these details, and I think it'll be cool. It's a cool list. I remember when he posted this actually. No, my YouTube partner manager keeps hitting me up. I really need to reply to them. Interesting. Cool. I have so many DMs to reply to later. It's crazy how it's like DB week now. I have a lot of thoughts on Convex. We'll get to those as we talk about my migration. I definitely recommend it, but it's a unique platform. It depends a lot on what you're building. If like you really want your database to be application focused, it's great. But all the other things like analytics, less so. Relatively new. Interesting. That's what we're covering next. Let's close all these guys. B. If you don't like JS in the backend, then you probably won't like my recommendations. You want to find people who are aligned with how you think about building in order to get the best recs. And even then, like their databases are so use case specific in terms of when they do and don't work and what they do and don't work for, that I don't like making blanket recommendations. The closest thing I'll make to a blanket rec is if you are scaling like Matt and don't want to think about it anymore, Planet Scale's probably your best bet. Cool. Let's do TanStack DB. I'm gonna grab a hoodie quick. 1 sec. How are we doing on time? 3 o'clock. I wanted to be done by 5, so let's blast through some stuff. Handstack DB. So I was lurking GitHub a few days ago, and I saw an interesting repo that I threw a star, and then it got renamed. This is that repo, Handstack DB. Oh boy, this is an interesting one. If y'all aren't familiar with Tanner, you should be, especially if you're a React dev, because Handstack query, also known as React query, is basically an essential dependency for all React developers. Handstack's been building a lot of other cool things, like routers, forms, and much more. But now they're building a DB. Well, kind of. The role of Handstack DB is fascinating, and I think there's a lot we can learn from it, but it's also one of the few Handstack projects I am pretty skeptical about. There's a lot to dive into here. Why Handstack DB exists, what it originally was, which is Handstack Optimistic, how it works, what it's actually here to do, and why is Electric SQL involved? We have a lot to dive into. And even though I am an investor in Electric SQL, none of these companies are paying me. None of them even hit me up about this. This is all me wanting to deep dive and figure it out. So someone has to cover the bills. Quick word from today's sponsor, and we will be right back. Okay. Let's make a new... No, it's a collection. I don't want a new collection. I want a new scene. Okay. Before we can go too deep, we need to have some ground rules, understanding, foundations, whatever you want to call it, about what is going on here and why we should care. I'm going to start with a somewhat bold statement. Optimistic updates. I'll just type it first. Optimistic updates in Handstack query kind of suck really badly. So in case you're not familiar with the syntax, Handstack query is incredible. Oops, I don't want to go to the GitHub. I want to go to the docs. Here's a basic example of a query using Handstack query. If you're, again, familiar with React query, this should look very simple and familiar to you. You have the query key, which is the identifier for this query. You have the query function, which is a function, optionally asynchronous. Usually asynchronous is why you use query. And now the results of this request are in data. Is pending lets you know if it's pending waiting or not. There's also when it's loading, other states as well. And then error, if you get an error, like if the JSON fails to decode, you get that back here. This gives you all the states you need to interface with asynchronous data in your React apps. And the query key is particularly cool because it means I can take this query and put it in 5 places. And the query key guarantees that they can share one cache entity. The fetch only has to happen once, and it can be referenced in all those different places. It's really nice. This example isn't type safe because it's a fetch call. We don't have type safety. But if you use something like TRPC here, it would be type safe, which is really cool. Because with TRPC, you know the type from back to front. And now you have the different states that you're trying to get in your client, along with all the type data you would expect too. So what's the problem? The problem is how optimistic updates work. So if we have a mutation, which is the other thing that React Query provides, is queries and mutations. Mutations are for things that change, queries are for things that don't. So on a mutation, like adding a new to-do to our to-do list, we post the new to-do to this endpoint. When that happens, we want to update the client with the updated list of to-dos. The lazy way to do this is to mark the query that has to-dos as invalidated so that it has to go be refetched. So what we're doing here is we call query client.invalidate queries with a query key. So as long as the query that we care about had to do as one of its query keys, it will now be forced back into pending state and it'll have to refetch to get new data. Cool. But that's not very optimistic. First off, if you don't get the key right or you're querying that data somewhere else with a slightly different key, then you aren't actually going to hit it. But more importantly, we're not updating it with the new to-do. We're invalidating it, so it has to do another network request response in order to get the updated state. So when you hit the submit button on that new query, so when you hit the submit button on that new to-do, you have to wait for 2 network calls. For the network call pushing up the to-do, and then another network call fetching the updated to-do list. So you're sitting there waiting on a gray screen, or sometimes not even, just you see the message disappear and you have to wait for it to reappear. Optimistic updates are hard. So let's see how we would actually make it optimistic. Sirens, one sec. If you want to update the to-do right when you get the submission, so I get the new to-do, I fire the request to the API, but I also want to update the UI as quickly as possible. I'll have to call cancel queries on any currently pending queries so I know they won't override the cache update I'm about to trigger. Previous to-dos, where I have to get from the query client the right query data from this key, which is not type safe, remember, because we're just randomly binding those keys in string arrays wherever we want. Now we have to manually set the query data and hope we got the type definitions correct. This is where the type safety of React Query falls apart, because there isn't a direct binding between this to-do key and the data that we are updating. So if this is expecting a string array, we could put a number in here accidentally and break everything, or we could put an object here accidentally and break everything, because there is no clarity between what this key is expected to map to, the shape of the data we get back, and the data that we update. All 3 of these lines here are incredibly untype safe and quickly can have problems if you change your keys or your expectations of the shape of data anywhere. The place that this gets worse is if we were to go change the shape of what is returned by the API endpoint, where instead of it returning a list of strings, it returns objects. Now we're just going to have random mutations all over our code base that are optimistically updating incorrectly and throwing errors. A couple good points from chat. This breaks a lot as your apps scale up. Imagine having to add filters on the to-do list. How do you handle the optimistic update there? What you'd have to do probably is you'd have to trigger the to-do list update with all of the data and then filter on client. But if you're trying to submit something and your query, if you're filtering on the server side and you're submitting a new to-do, you don't know if that to-do passes the filter that you have on or not. This stuff sucks. These are problems I would not wish on anyone. I've been there. I've done that. I hated it. You could also brute force type safety by doing a bunch of like as bindings everywhere, or if you have all of your queries defined manually in like a key value store somewhere, you might be able to force type safety here, but I haven't seen anyone pull it off elegantly. I haven't read this post. TK Dodo, the legend who maintains React Query and Tanstack Query now, has an incredible blog breaking down the way to like think properly in React Query. And there's a new post that is focused entirely on optimistic updates. And as I read it, my head hurts more and more because this is the most complex I've seen one of his like posts have to get, because it's a complex problem. As he puts it, you have to recreate server logic on the client. With optimistic UI, you're essentially trying to foresee what the server will do and implement it on the client beforehand. It's the word. Okay, the word type safety doesn't occur on the page at all. So all the examples in here are actually not type safe either, which is terrifying. So this post is cool that it like breaks down the timeline of when things are happening and changing, but fixing the like consistency and type safety problem is non-trivial. So I think we've established optimistic updates in TanStack query, not great. Hopefully you guys agree. Hopefully Tanner and crew aren't too mad at me for saying this. Optimistic updates in TanStack query suck. It's a consequence of the data model, the nature of simplifying, and it's a combination of the data model, simulating all of the horrifying things from the back end in order to make the UI do what it's expected to, the weird nature of keys being bound however you choose. There's a lot of pieces that make TanStack query not great for optimistic updates. So we've established this point. Now we need to talk about the two pieces here. TanStack optimistic, aka TanStack DB. And we need to talk about electric SQL. I'm going to start with electric because I think it'll help a lot with the context here. Again, disclosure, I am an investor in electric. I don't talk to them a whole lot. We disagree on a lot of things, funny enough. I go to their meetups here and there, but electric SQL is an interesting product. Their goal is to build a sync layer on top of Postgres. You have data in your DB, you replicate the portion relevant to a given user or client, and you fan that out to whatever clients it's relevant to. So when you make a query or a mutation, or more importantly, you make a change to the DB, the change gets sent out and replicated across the different clients. There's a couple of these different... Oh, there's a type-safe React query cover optimistic updates, though. It does not. Stop gaslighting me. Type-safe React query, fine and dandy. Type-safe optimistic updates, nope. This does not solve the problem. This does not solve the problem at all. The problem is if I call to-dos in 4 different places and I'm not very anal about making sure all 4 have the exact same type definition, or I give something else a different key, then I'm fucked. I have to make sure every single time this type definition is called, this key is called alongside it. Like if these 2 aren't always touching, everything falls apart. And there is nothing guaranteeing that they're touching. There is no link between these 2 things other than us putting them there. The type safety of React query falls apart as soon as you leave the component you're in. That's just the nature of how TRP or of how React query works. I'm not trying to, like you guys know, I'm a huge React query fanboy. I need to highlight that these things being separate guarantees you have skew in your type definitions. Your types are not guaranteed to be linked. You've effectively guaranteed that at some point they will be unlinked. The solution to that is something like, it was linked in here, React Query Kit, which forces you to instantiate all of the query types via a create query call. Now you use this use post and you can invalidate it by calling like invalidate on this thing that now has types. This is how TRPC does it now with React Query too, but like this is the solution you need. is you have to build a whole fucking layer and package on top of React Query in order to fix this problem. I didn't think this was going to be relevant, but FaZe, if you can cut that whole tangent I just did and throw it back to when I'm trying to explain the React Query type safety problem in particular when I'm in the blog before we go to Electric, that'd be cool. Back to Electric. Electric's goal is to work with any Postgres database and any JavaScript-based client you want to connect things to. But that means there's a lot of pieces they have to think about. They have to think about authentication, which is really difficult here because you have to know which rows in the database a user has access to, so they can't force it to sync someone else's data. So now you have to, at a database level, define your authentication. Row-level security is basically necessary in order to do these things. You also have to handle the client side and how you integrate the synchronized data, how you mutate the data, how you optimistically update the data, how you do all of that on client. Getting that right's really hard, especially if you're trying to make it integrate nicely with things like React Query. I know this because I've seen a couple different approaches historically. I saw how tRPC did it and then changed how they did it recently, and I saw how Convex did it, and they decided to just not use React Query in particular because the optimistic layer was not good for it. If we look through my code base for T3 chat, which we recently started moving over to Convex, hopefully it's the default by the time this video is out. We're trying to ship it officially by Friday. If you want to try the beta, the opt-ins and settings. Here I have update thread title mutation. This is when a user updates the title for a thread. I have my API threads update call, which is a type-safe call referencing a backend function that exists here. And when this is called, I have access to my local store, which is my Convex storage, and the args, which are the arguments that were just passed here. If I call local storage.getQuery with this query identifier and this value, I know the type of what I'm going to get back. It's thread with parent or undefined. This is awesome because now if I make a change, I know what type I have to honor. And if it doesn't exist, or if it does exist, if it's not undefined, then I find the current thread in this array of threads. I then return the thread with the title updated. And I then set it to the new object. This is still more steps than I would like it to be, but this is so much better than the equivalent with React Query, because instead of each of these being a violation of a type contract, each of these is fully complicit with the types. I am still replicating the server-side code myself because I am grabbing the query that is listing all of the things on the sidebar. I am updating the one that you changed, and then I am setting the new state. So technically speaking, yes, I am replicating the server-side logic. And if we were filtering on the server side, like your threads, hell, if you were searching for threads and you updated one of their titles, it wouldn't hit this. You wouldn't get an optimistic update on a thread that is coming up through search instead of through the traditional sidebar query. Still a lot better. But in the end, this is us replicating backend logic on the front end in order to show you the change faster than it waiting for the backend to send you the update. So how is this being solved by Electric? Well, Electric's platform and product isn't directly solving this. The Electric core thing, like if you go to GitHub, what they built here is a backend. Funny enough, written in one of my favorite languages, Elixir, which handles concurrent scaling, WebSockets, all these things really, really well. Makes a lot of sense they built in Elixir. I'm a fanboy. It's part of why I invested. But this is a server-side infrastructure for taking a Postgres database and synchronizing partial pieces of it across different clients. They have a cloud product for hosting it. And the most important piece, PG Lite. Sync into a lightweight WASM Postgres with real-time reactive bindings. This is a library that they built to have SQLite, well, PostgreSQLite, largely learning from the SQLite WASM project. PGLite has the goal of letting you run Postgres queries and replicate Postgres data and patterns in the browser. So you can take a subsection of your database, put it in the browser, and query it. And it works in WASM, so it works anywhere that WASM is supported. All of these come together with the TypeScript client from Electric that lets you create a shape stream. Their concept of a shape is like, it's their abstraction on a table, like something in your schema, in order to give you the primitive that you're querying against, the tables it has, and the shapes of the parts that you can get from it. So here we create a shape from this URL with these parameters, and we can create a stream from the shape, or then we can create a shape from this shape stream that will automatically update or call its subscribe function when changes that are affected from here occur. So you can build on top of this a pretty powerful sync engine that will take a given endpoint, connect to Electric on the back end, see when something changes that's relevant to your query, and then fire this update when that happens. But as you can guess, looking at this code, not going to be very fun to build the whole sync engine and layer for this yourself into your application. So what do you do now? What most people do is they build a React library, which is why we have Electric SQL/React. This is their React hooks in order to bind a given URL and the parameters you're passing to it with Electric SQL on the back end to get that data on the client and have it auto-update when it changes. I would imagine this package has very little code, but more importantly, this package is probably not super well maintained because it's not core to their business in the sense that it is not the thing they are selling. They are much more focused on the infrastructure side. So how do you handle that? If you have a React package that's kind of just sitting there, 20 lines of code trying to replicate the shape of TanStack query, you want to focus on the infra side, and the core problems you care about, like optimistic updates, aren't well solved with the ecosystem. So you can't just build into TanStack query because it's not going to solve the problems that your product is built to solve. It's not going to let users take advantage of how easy it is to do those things. Because Electric SQL has replicated the DB, it can just write the change locally and update you immediately. But if you can't optimistically do things with it, it falls apart. They have examples here using TanStack query, and you'll see how quick they get super complex because it has to write all these crazy additional hooks, including the use mutation state, to show the temporary mutation data. Instead of adding it to the data from the query, they now have a case in render where if they're not in a clearing state, they create a map of items where they take the ones from the query and they add the ones from the mutation. So your render code has to get fucked in order to trigger this optimistic update. It's rough. And that's the point where they decided to reach out, not to try and bully Tanner and TK into fixing optimistic updates in React query. Instead, they recognized how big of a gap it was to care this much about local optimistic updates and proposed a new solution, which was TanStack Optimistic. And now we have finally made our way to what we're here to talk about today, TanStack Optimistic, which just got renamed to TanStack DB. Let's see how they describe it first and foremost. TanStack DB is a reactive client store for building super fast apps on sync. Extends TanStack query with collections, live queries, and optimistic mutations that keep your UI reactive, consistent, and blazing fast. Prime reference. Here's the post on Twitter that I think does a good job of breaking down why this exists. TanStack DB is a reactive, normalized, transactional state engine that extends TanStack query. It gives you collections with live queries, sub-millisecond incremental updates via differential data flow, fine-grained reactivity for minimal re-renders, robust optimistic transactions with sync lifecycle support, and normalized data by default. Think of it like Tanstack Query meets client-side databases, perfect for local-first, collaborative, or offline-friendly apps. As someone who tried building this myself, this sounds very nice. I've been in hell building sync engines. It's backend agnostic, incrementally adoptable, works with REST, GraphQL, sync engines, polling. You'll see GraphQL come up a lot in this circle because one of the co-founders of Electric is Kyle, who's also the creator of Gatsby. I won't make further comments on what that does to my thoughts on where this could go. The pairing seamlessly with Tanstack Query is the part I am the most excited about by far. So what does it look like to use? Well, first we have to create a query collection. As a query key, query function that actually gets the data, an ID, so that we know how to get IDs out of this collection of to-dos, so that each item is uniquely identifiable, so we can do granular updates. Because if we change one to-do in a list, but we're getting the whole list as a collection, we don't want to re-render the whole list. We want to just re-render that one item. So each item needs to be identifiable, similar to like a key when you're rendering a list of stuff in React. And then the schema, which is any standard schema. Think Zod, Validbot, archetype, those types of things. So now we can get our data, which is to-dos, from the live query from tanstack/react-db. And that is a query from to-do collection where at completed, which is a field that the schema has defined, is equal to false. So this will give us all to-dos that are not completed. There are catches here, though. You might be seeing them. The one I am seeing, what the fuck is this? There is now yet another query syntax being built. We'll go into why I'm skeptical about that in a little bit. What I want to talk about is the optimistic part. We now have a use optimistic mutation hook. Const collections, comma, modified, new to do. We have this transaction. We're grabbing transaction.mutations 0. So the first thing from this list of transactions, in case you batched a whole bunch, but it might not exist. So you have to do an exclamation point. We're already losing type safety points. We then await api.todos.create, new to do. Await collection.invalidate. Huh? Is this not everything we were just doing? Where does this even get the thing that it's operating with? Oh, on click, add to do.mutate, this has the transaction passed in line when we do it. So we don't write a mutation that this optimistic mutation works against. We call this as a generic and we pass it the mutation we actually want to do in the collection we want it to operate against. Yet implementation details are leaking here. This is why I'm confused about this. On one hand, it's more type safe because it knows what to-do collection is. But on the other hand, this is taking the problem with React Query and making it 10 times worse. Because in React Query, a given use mutation call has one mutation function that it is bound to. A given to-do mutation that you have will closely tie the behavior of the mutation to the optimistic update behavior too, because they're the same mutation, and that one mutation can do the one thing. What happens if I pass a different transaction to add to do? Everything falls apart very, very quickly. If I had a different thing I was passing here, like update to do, and I accidentally called this, Or if I had named this instead of add to do, mutate to do. What we do in it is we create a to do, but if we accidentally did something else with it, it's going to break really bad. The fact that these implementation details are leaking between here and here instead of being defined in one place and then called in others is terrifying to me. The closer your update and your logic are, the easier life gets. And this is, again, something like, I hate to just be plugging Convex this whole time, but one of the things Convex does really well, I have this client-side front-end code where my existing threads are being grabbed from this query that I fired other places. I have the type definition here for it, but more importantly, if I command click, it brings me to the backend function that actually does this. And yes, they have their own weird syntax here to an extent. Their weird syntax is how you hit things with indexes. Where things get really fun is when you want to do something like link data, like I do here where I attach parents to thread. You would think that I would include that in the query semantics here like you would in SQL. But due to the way Convex works, I literally just map through them and await the fetch to get the parent. Yes, really. You just map through or for loop through all of the data and just query for each row. It seems insane, but the way Convex works is it flattens all of these into a single transaction, so it ends up still being really fast. There's a lot more nested than I normally like. People are calling that out in chat. You're correct, but it's fully type safe and it is just JavaScript. Like everything I wrote here is vanilla JSTS. Nothing special exists here at all. One of the cool things is that the strings they use for IDs are branded. So it knows thread.branchParentThread is a thread ID. So it knows branch parent is a thread. If I passed it a message ID instead, it would know this is a message. So you get full type safety at every step. And when I'm in my client here, my update thread mutation has this one function it can ever call. And the optimistic update is directly tied to the one function it can ever call. That prevents a lot of the drift that could be a problem here. And the thing I am concerned about when I look at that, and the thing I'm concerned about when I look at this is how easy it is to have drift between your update logic on client and the shape of the things you are passing to the thing that does that update. Ugh. Let's keep reading. Collections support insert, update, and delete operations. These operations must be made within the context of a transactional mutator. So we create an optimistic mutation, which is a mutator. And the mutator has to be passed a transaction. We trigger a mutate function, which immediately applies optimistic state. So to do collection.update to do, comma, draft dot-completed equals true. Rather than mutating the collection data directly, the collection internally treats its synced and loaded data as immutable. It maintains a separate set of local mutations as optimistic state. When live queries read from the collection, they see a local view that overlays the local optimistic mutations on top of the immutable synced data. So you're not actually updating the data from the server. You're creating a copy of it, changing that, and rendering that on top temporarily as you wait for the real data to come back from the server. Funny enough, I actually do this as well. My use thread data hook, this is the hook that calls session query to get my threads that are listed on the sidebar. I grab them from Convex, which is why I have this threads from Convex. One of the things Convex does that I don't like with their hooks is they don't return loading data error states. They just return the thing or undefined as the fallback. So the only way you know it is loading is if it's undefined. And if you could actually return undefined, good luck. I love Convex. This sucks. They know this sucks. It's going to be a fun one to fix. So what I do in order to make sure when you load the beta, and I'll go do it now. I'm not signed in on here. Cool. I'll load it in the browser I use every day. for testing it. Cool. So in the beta here, you'll see when I load the page, the sidebar is there immediately. I'm refreshing. Sidebar is always there. The reason the sidebar is always there is because I back up the results in local storage. And whenever they change, I update the local storage results. So on first paint, I can return the local storage values if I don't yet have threads from convex. This is my attempt to skip the whole waiting for the server to respond with the data in order to show the user something faster. It's not the exact same as mutations, or it's not the same as optimistic mutations, but it is very similar. And the point I want you to take home here is this custom data thing that I have, threads from local storage, which is the same shape and expectations that we have from the session query from the backend. Here, I return the thread from convex first, and if I don't have it, I fall back on local store. Imagine if we had flipped this. Threads from local storage gets returned first. Threads from convex is the fallback. Now, if we make changes here, this will be shown first. And if, when this completes, we nuke it, we just, on a change of threads from convex, we wipe the local store. That's how this works. The magic here is that your state from the server stays pure. It's always the exact thing the server returns. You just have a mirror of it on top temporarily. And the moment you decide that isn't the thing you want to return to your user anymore because you have new data, you just destroy it. It's a very sensical pattern, and I'm excited to see them embrace it. But I am curious how much the implementation details have leaked, because this kind of sucks. The idea that I have to pass this here somewhere in my application logic, separate from the hook I defined up top, I don't love. I really don't love. Oh shit, Convex is here. Good to see you, man. I've been trying to not just glaze Convex this whole time. Yeah. I did compliment how Convex does optimistic updates earlier. It's the least painful I've dealt with. And as much as I hoped for this to go that path, I am skeptical. Cool. Back to the docs. The local mutations are passed to the async mutation function that's passed in when creating the mutator. This mutation function is responsible for handling the writes, usually by sending them to a server or a database. TanStackDB waits for the function to resolve before then removing the optimistic state that was applied when the local write was made. My cat is screaming at the door. We're going to do a quick hello, and then I'm going to kick him out. Anyways. Sorry, if you keep screaming at the door, I'll be way too distracted, and we have limited time today. So, one more quick piece. You might be thinking, as you look at the code here, well, I have this too with Convex. The update logic's in a different file. Because if I have my editable thread title here, the code that actually updates the thread title, I have to command click to get to it. And this is a whole different function. There's a whole bunch of different stuff. Isn't that the same thing? This is an implementation detail leaking out of here? No, because that's the backend logic. And this has the same problem too. Despite how much we've just looked at all of this code to do these things, despite the fact that we've written all of this for our mutation, the backend logic still has to be written. Your API call that lets you create a new to-do doesn't exist here still. You have to go write that, validate the user can do that, have the row level security and everything set up properly, all just to make sure the user sees the right thing and has the right permissions to do the thing. So all of that additional backend logic still has to be written. This is just for showing it to you on the client, and we're leaking the abstraction so aggressively still. This is making me long for my original T3 chat solution. I feel bad even talking about this because it's so wrong. But when I started T3 chat, we did some fun things with Upstash. Upstash is a Redis KV. So we have our Redis KV. We have a bunch of clients. So we'll say this is user 1. User 1 has a whole bunch of threads and messages. Let's just say they have threads. It's some crazy array. We'll just say they have like 27 of them or something. And they have messages, another crazier array. We'll say they have 120 of them. The intuitive thing is, oh, every thread and message should just have its own row. But how do I know which messages this user has access to? How do I handle all the logic and all the back and forth there? How do I get all of it synced down to the user without firing thousands of queries and mutations? I would gzip it as JSON. So JSON I would JSON it. Yeah, I'll do this the right way. I would JSONify it, then I would gzip it, and then I would store it in here as user1 key, with user1 as the key, and the value is your gzip blob. And this was honestly magical. It was one of the best data architectures I've ever gotten to work in, as comically simple as it was. The only reason this failed is once the messages started getting huge, people were pasting giant blobs in. The thing we were syncing got bigger and bigger until it was multiple megabytes. And it started to fall apart at that point, especially because we had to sync down the whole multi-megabyte payload back and forth every time. Not great. So I have a whole video about the database architecture changes. I'm going to do another one soon about the convex stuff. The point I wanted to make here is that this was beautifully simple, because if the client could do it, awesome. Because the only auth here was that when you wrote to our API, I would take your user ID, which we authenticated was you, and I would write to the DB with that key, and this is the value. So if you wanted to fill it with garbage, you could. And it would sync up totally fine, because I don't care. You can't override another user's things. You can't access another person's stuff. Your key is yours and only yours. And the result was very simple and easy to maintain. And then it fell apart as I had to handle all the crazy edge cases that come up, like multiple devices, or breaking things up into individual message and thread rows, or handling streamed updates when they come through on the fly and have to be resumed. This was beautiful until it fell apart. And I long for this setup dearly still. I wish I could do this again. I know I can't. I know it's irresponsible and wrong. And I'm telling you, do not do this. It's not a good way to do things. but it meant all of the problems we're talking about today did not exist, which was really nice. And when I see this, I see code that is more complex than what I had done there. And it's obfuscating half of it because we don't even see the backend side here. So, yeah, benefits and negatives to all of the above. I'm skeptical of this flow. Here is how they diagram it, where a given component will trigger an optimistic state change to the collection, while at the same time a persist mutation is going to the server. When that happens, a sink comes down to the collection, which nukes the cache that they have on top of the collection when they mirror the data to make the optimistic mutation, and that will then update the component yet again. So why would the architecture end up like this? How did we get here? My hot take with that is this idea of collections. We have this whole section defining collections, which are type sets of objects that we populated with data. It seems like from all the examples they have, they are calling an endpoint with it. Do I even have an example of creating a collection in this here? Okay, here's one. To do collection, we create an electric collection. ID, stream options, primary key, schema. This is the deeply integrated version with electric. We give it the URL. We give it the param for the thing we want to do. We want to hit table to-dos. We tell it what the primary key is from the thing being returned. And now we've defined this collection. Does this look familiar to something we saw earlier? Oh, look, they even link it underneath. Shapes and shape streams. It seems like this concept of a shape is very core to how Electric is thinking about databases and sync engines. And rather than rethink optimistic updates on client in a way that made them more consistent and reliable, they were trying to figure out how to fix them for shapes. And this is the hot take I have. TanStackDB should never have been named TanStack Optimistic, because that's not what it is. It's TanStack Optimistic Shapes. And now TanStackDB might not be best to call TanStackDB. It's certainly clickbaity and gets a lot of attention in order to get people to watch a video like this one. Hi, thanks for watching. TanStackDB would be more accurately described as TanStack shape bindings, where it is giving us this idea of a shape that comes from Electric and make it easier to interface with using TanStack patterns. On one hand, I'm thankful they did this instead of making yet another crappy React client that has to be maintained indefinitely and falls apart. But on the other hand, I think it's misleading, and I cannot imagine many people using this outside of the Electric case. And it almost feels like an ad/top of funnel to get people on Electric, which again is a company I'm invested in that I want to see succeed. I will make a lot of money if they do. This just felt weird. And I remember when I first saw this, I was at a local first meetup and I saw an excited presentation. The repo had 7 stars and I was the 8th. And the more I read, the more skeptical I got, because this idea of a collection does not map at all to the idea of a live local database or a sync engine or just basic optimistic updates that I was looking for. Chat put it really well. It sounds like it's supposed to be a generic, but it is far too specialized to be useful beyond. That's how I feel too. The amount that the implementation details are leaking all over the place here just doesn't feel particularly TanStacky. Like with TanStack, you just give it an async function and you're good to go. That's not the case here at all, because the async function you give it, even with something like this, you're no longer getting like any of the benefits of the update, the sync, and all of that. At that point, you would want this to have a subscription of some form. Now you have to define all of your endpoints in the shape of what this expects. I cannot imagine having a great experience with TanStackDB right now if you are not shaping your backend to fit the expectations of this library. And the point of React Query was the opposite. It lets you not care about the way the backend was shaping your data. You could just call an async function, get what you want, and go on with your day. This does not feel like that at all to me. And I hope they take this feedback as an opportunity, because that's what it is. I desperately want better ergonomics around local updates. The React Query kit seemed pretty good. What I have here with Convex, with like a type-safe local store primitive, which is a confusing name. I already told them to not call it that because it's easy to mix it up with local storage. But this is the Convex client's state of the world. This isn't the most fun thing, but it's fully type-safe. If I make a change to type definitions, this will get type errors. It does what it's supposed to. The code I wrote here was exactly what I expected to, and it worked exactly how I wanted it to first try. This is nice. And I was hoping that TanStack Query Optimistic, and I was hoping that TanStack Optimistic and now TanStackDB would feel better than this and less leaky than this. But what I'm seeing is quite the opposite right now. What I'm seeing here is a huge shift in our database model, thinking about how permissions and endpoints and synchronization work with a PostgreSDB, with implementation details leaking not just into your React client code, but into the libraries that we hold dear, because normally they make our lives easier. If this way of building makes sense to you, I'm sure this library will be very helpful. But I was really hoping it will be more useful to more people, and I hope they take the opportunity to do just that. Hope this was a useful overview of TanStackDB and what's going on in the database sync engine world. I've been way too deep in this stuff for a while now, and I hope you got something out of it. Let me know what you think. And until next time, stay optimistic. Cool. One more down. WebSocket connections are surprisingly cheap. That's the thing that makes Convex so exciting for me. Yeah, Kyle must live. I didn't want to like say that too loudly because I didn't want to like make the whole thing me going after one person, but I do suspect a significant portion of my frustration with the library is my, how do I put it? It's my like philosophical disagreements. It's the same reasons I hated Gatsby. So about half, it was like 2/3. Now it's about half of my investments were through Anderson Horowitz Scout Fund. So technically it's not my investment. And One in Electric was A16 Scout. So it wasn't my money, which means technically I'm not an investor. I don't have to disclose because A16 is the investor. It would be almost the equivalent of like, if you have a 401k, you don't have to disclose that you're a Microsoft investor. But I know better than that. I know the expectation people have, and the fact that I have an earmarked chunk of an investment that, if profitable, will be sent to me as part of the A16 Scout Fund, then like, you guys know what that implies. So I just say I'm an investor because I want to account for biases there. But now, especially with the recent YC batches, I've been investing my own money because they're really exciting. And I don't want to give the equity to another firm. I want it to be mine. So most of my recent investments have been out of my own bank account. Smaller checks, more of them. And believe me, we're on it. Will it chat in-house or use a chat provider like Songbird? Littlefinger, I will say, because he doesn't want to overpromise, definitely DM Jam. He's been fucking awesome. My gut feel here is that if you are cost conscious, the biggest expense will almost always be engineers and their time. The reason we're moving to Convex is because my experience with the sync engine was basically required to make changes to our data model. Now every engineer can do it, which is a huge unlock that I would pay an absurd amount of money for. And the insights and simplicity of the Convex platform mean that if I see it's expensive, I can make adjustments to fix that more easily, because there's much... The dashboard is the real killer feature in Convex in a lot of ways. It's much easier to find what is costing us money. Like, we're doing an insane amount of read throughput right now, even just on the beta. And I know why, because I saw the query that's causing it. The query that's causing it is the get thread by ID query, because I, upon page load, immediately query the top 20 threads so that when you click one, it will load immediately because I've already queried it. If I wanted to not have 40 to 60 gigs of data transferred a day, I could turn that off right now. Maybe I could move it so that we do the optimistic query on hover instead. Or I could do just the top 10 and cut the data in half. There's a lot of things I can do that would make this use less data, and the platform makes it really easy to find those things. So that's my take on it. Other alternatives, like, I know there's a lot of these like chat as a service things. Fuck, what was the one that I used at Turntable? I can't even remember. There's so many. I know a lot about Ably, which is more WebSocket as a service, but they're focused on chat stuff. There's a bunch of those. And when your model for what you're doing with it doesn't perfectly align with like their costs, you'll quickly end up in a hole that you can't really engineer your way out of. Because if you need to do something the platform doesn't do, you have a huge cost to deal with. Oh, if you're already on MySQL and you want something that you'll still be on MySQL but think a lot less about it, you have to do Planet-Scale. Like, if you are on MySQL and don't mind staying on it, it's such a good option. It's still like, whenever I don't use Planet-Scale, I feel a little irresponsible. Even the fucking CEO of Convex is in here. Please use Planet-Scale. It's so good. Yeah. I'm screenshotting this for reference for later. Yeah, no return on inserts like the problem with MySQL, and honestly, it's fine. Not that big a deal. Will I use 0 when it's out of alpha? I've played with 0. I think we need to do the migration video now because I want to talk about all of this. This will probably be the last one for the day because I have a feeling it's going to be a long one. And I have a feeling... Oops, I want to close all of those. I do, actually. Yeah. And I have a feeling this was going to be a bit of a mess because the migration itself was a bit of a mess. I want to like notate out the pieces I am covering here before I film this one. Brief overview of previous DB states. List of things I want. Zoomable streaming. Server driven updating of client. No more or avoid split brain at most costs. I just remember I have to check something in my editor so I make sure I don't leak environment variables. Cool, I would not have leaked environment variables if I had done the thing I knew I would do while filming. Cool. Wait, split brain at most costs. Index it. Drop indexed DB. Good optimistic updates still. The biggest thing, my team can actually maintain it. And the migration. And this was basically a rewrite. I had to figure out auth. Signed out states. It's a big part there. Session management. Trying to think through the pieces I had to deal with as I did this. I just kind of want to go through the PR and merged. Think overhaul. My commit messages, trying to be a good boy, Dexit has started. What was this? Ah, yeah, that was my partial change. 109 hidden items, Jesus fuck. I'm gonna open this up so I have that to reference separately. God, this destroys GitHub entirely. Session auth management. I think actual data migration from P-Scale is a good part. I'm gonna put first part, rethinking the schema. Cool. The issues. The dreaded migration loop. Migration failures from large messages and old data. Cookies in all sorts of broken states. WebSocket connections dying for no reason. Stale JWTs were old JWTs with bad formats were the issue. Cool. Okay, I think that covered the other data migration loop, search indexing exploded. Okay. Anything exploded. Plus local caching. Cool. So the thing I have to decide on is like how I brand this. I've been thinking a lot about like what this video is. Because like what it actually is the migration story. But what I think I want to brand it as is I gave up on local or I gave up on local first. But I'm trying to decide if I gave up on local first is a separate video or not. Is this 2 videos? Yeah. Split it. Okay, there will be a separate why I gave up on local first vid. That'll also simplify this one a bunch. Cool. Fuck it. I think we're ready to go. God. Cool. I set this to not be slept. Why is it still getting unloaded? Whatever. Oh shit, thank you for the 10 bomb negative. Really appreciate the gifts. We gotta get started though. Let's do it. Yes, I really changed databases again. I know, I need to stop doing this. You've probably already seen the video where I talked about the other 3 database changes that I made. Well, I hope this is the last one because it has been a wild ride. I have so much to share here. This is going to be both a thought, or we're going to be going deep on the new database I chose, which, spoiler alert, it's Convex, how I got there, what we're seeing as the benefits of it, and why this migration took 5+ years off of my life. I had the most chaotic debugging session that lasted like 4 days. I effectively thought I was solving a murder mystery at a point because I was so deep in. I wouldn't wish what I went through there on anyone. And before we go that much further, I want to clarify that almost none of it was Convex's fault. But I think there's a lot to learn here, both from the hellish nature of this debugging that I had to do and the painful 11:50 p.m. on a Friday ship we did that broke things for a ton of users, and how we finally got to a place where I am confident enough in our database setup that not only am I ready to hit the go button and ship it to all our users, but I feel like my team is finally unblocked. The goal of this whole migration was to make it so the other engineers working with me on T3 chat can make changes more confidently. Because as great as parts of my sync engine were, oh man. So if you want a deep dive on how to think about database engine, so if you're excited, so if you want to, how do I put this? So if you're interested in a deep dive on everything from sync engines to chaotic authentication debugging stories to a set of patches being made on the Brave browser due to things I found in the process, you're in the right place. It's going to be quite a video. But after losing multiple nights and years of my life to this one, I'm going to say a thing I very rarely do. I'm underpaid. So let's do a quick word from today's sponsor, and then we'll get right back to it. So before we can go much further, we should do a quick overview of where things were before the migration. Things started relatively simply. I actually talked about this in a video I filmed a little bit earlier today. This is the setup that I previously had when we launched T3 Chat, and I miss it dearly. It was so simple and so consistent, but it had problems. The TLDR is that I had everything locally on your machine using Dexy, which is an IndexedDB wrapper from a forgotten time. You can tell from the website. Dexy was written with IE 7 and 8 support. Legendary library. It has made my life much easier. But syncing it was a challenge. Oh shit, I didn't see Keith is here. VIP, GNU, Keith. Good to see you, man. Thanks for stopping by. It'll be a fun one. Cool. So all of your data was stored in the Dexy IndexedDB instance. IndexedDB is a browser API for storing large amounts of data in a key value store. It is a mess to the point where I'll be doing a separate video why I'm giving up on locals. It's such a mess that I have a whole separate video planned about it. It's going to be why I gave up on local first, because IndexedDB is the browser API to make local first possible, and it is a shit show. I couldn't recommend it to my worst enemy. It is painful. I don't want to make this video about that, but I'm going to give one quick example. A given IndexedDB instance can only have one connection to it in the browser. So if you have two tabs on the same app, only one of the tabs can be connected to the IndexedDB, which means all the other tabs have to handle things through events and message passing between each other. It's so bad. It's so bad. So I could spend a lot of time complaining about all of that, but instead we're going to talk about where things actually went. So we stored all of the data locally in your IndexedDB instance with Dexy. I had your threads and I had your messages. I would JSONify those. It was actually super JSON, so things like dates would be honored in the serialization. I would then gzip it so that it was a much smaller binary. And then I stored that in Upstash, which is a Redis KV. The key being your user ID and the value being the gzip blob. Also, the Brave people fighting Brave issues have been benefiting a lot from me. We'll be going deep on the Brave stuff, don't worry. But first, we need to talk about my database, because my database was very simple. A key value store where your entire database instance was serialized and thrown in here. So when you sent a new message, and the new message was generated by our AI and shown to you in the UI, on complete, I would update the IndexedDB instance and then trigger the update function that would rezip up everything and post the whole thing up. I did some testing where I had like hundreds of threads with tens of messages each locally. And after gzipping it, it was only like 600 kilobytes. So I was like, okay, this is going to scale pretty far. I should be fine for a bit. I did not expect users to paste like the entire documentation for 3 different libraries and their whole code base in as messages, which caused this to break for a small number of users very badly. Which is why I then broke it up to have threads and messages as their own separate keys in the Redis instance. But I had to make sure that you could only update things that were yours, so the keys became something like this. We had like message colon user colon 1, so that's the user ID, colon some UUID, which was the UUID they had generated for the message. So if they were faking it on the client and trying to override someone else's messages or threads, they couldn't, because in Redis, they were identified by the user ID as part of the key. This made things significantly easier for us for persisting. And if you were a signed out user, you just couldn't persist at all, which made things extremely easy. Until you had to query for thousands of things in Redis on page load. Then it fell apart pretty aggressively. Or if you had a thread and it needed a bunch of messages, the threads didn't keep track of the message IDs. The messages had message IDs in them. So I would have to download all of the things from Redis for you as a user and put them all in IndexedDB and then do my best to sync up the right changes at the right times. And I got it mostly working. And then I saw how insane our throughput was on Upstash and realized that I needed traditional DB for this, especially because we're doing more relation-y stuff. So I spent 2 days doing this move, and then I spent 2 hours taking this and throwing it on planet scale using Drizzle instead, which was surprisingly easy once I broke it up into individual things. But there's an important detail on how I did that that will be the start of everything we're about to cover. Let me get status. No, this is the wrong one. Cool. This is correct. SQL schema. This is the schema for our messages in threads when we were on planet scale doing traditional SQL stuff. Notice anything that makes you concerned. There's one thing in particular that should raise red flags. Here. I wasn't storing a bunch of different keys that represented the data for your message or the data for your threads. There is no status, there is no content, there is no title, there is no model, none of the things that we expect. None of them are mapped here. I only mapped what I had to in order to handle the absolute fucking chaos that was taking your local synced data and putting it up on the cloud and updating the right parts. So this data field is a super JSON string, which, by the way, super JSON bloats the size of these have done. So we probably were storing 4x more data than we needed to. Fun mistake to learn from. So how is the data shaped? It was shaped in the folder that ruined my life, local DB. Here is the DEXI code that no longer exists in the main branch. Deleting this was such a career high for me. Here we have dex thread, which is the thread that is stored in IndexedDB. So when you do things in the original T3 chat implementation, you are touching your local IndexedDB instance instead. So I update a title, it changes here in DEXI locally. When this gets persisted on the server, I take the whole value that I have in IndexedDB, I stringify it with super JSON, and then I post that up where it gets written to the DB. So the actual content is all defined here, which is particularly nice because it means we can make changes to the shape of data without having to do database migrations. It also means we can do experiments, we can have different things going on in dev, and most importantly, everything relies on local. So when you do things on the client side, the server just maintains the history of what you've done. It doesn't care about the shape of any of it. Then I had to start dealing with all the problems that come when you build your own sync engine. Like the one that's haunted me forever now is delete persistence. I've changed how we manage deletes probably 5 or 6 times at this point and never quite got it right. We always get new reports of deleted threads and messages coming back because no matter how many different ways I try to set it up, we hit some edge case that breaks. So it's annoyed me forever. That all said, since it's all local, we can do things like set an ID that's part of the URL and set it on client by just calling crypto.random UUID on the user's device. And it's fine because this all gets serialized in a JSON blob that doesn't allow you to override other users' things. Even the ID value, okay, this ID is just an increment coming from MySQL, but the user provided ID, this is the ID that the user gave for the message, and I append the user ID in front when we write it. So it's the same pattern I showed before. But man, were we hitting a lot of edge cases. The biggest edge case being IndexedDB just not fucking working in a bunch of places. I don't even want to think ever again about all the race conditions we were hitting in Safari. I am so happy to have exited IndexedDB, and I feel bad because DEXI was awesome. It's one of those rare gems you find that takes an API that's so fundamentally broken and makes it totally usable. DXC did such a good job of making things usable for me inside of IndexedDB that it misled me into thinking IndexedDB would be a good choice. Oh, look at that. Look at my cute innocence. 4 months ago, the original commit where I did this. We are local, baby. OMG, this is so good. I miss that innocence so much. I wish I could go back to how I felt when I thought this was all going to work. Oh, man. Anyways. So, in order to understand where we ended up, we need to talk about what I wanted. So, the key things I wanted. First and foremost, as we've established, I wanted off of IndexedDB's wild ride. I was out. We'll do a dedicated video about all the weird quirks and shit I dealt with in the time. Just trust me when I say it's not worth it. It's just not worth it. I also wanted to solve the split brain problem. When I say split brain, what I mean is your definitions living in multiple places. Even here, where I have the actual definition of what data we have and use living here inside of the IndexedDB DXC stuff, I have a separate message table that is a different shape. Thankfully, this one is just a key within it, but that's still two different things that have their own consequences. I also just got a huge gift bomb, so huge shout out to Blazingly Slow for throwing another 10 bomb here and getting this hype train moving. Thank you for that. And HD doing the 10 bomb earlier too. Appreciate all you guys for the support. Another 5 from HD Negative. Thank you guys all a ton. I'm going to come back and thank all the other subs after I finish filming this one, and I'll give you guys a more proper thanks when we get there, but I'm on a somewhat limited schedule for time right now, so I want to get this done before I lose my train of thought too hard. Yeah, I was going to get to this part, don't worry. Yeah. So, this data lives in multiple places, which means there isn't really one source of truth, so to speak, especially because different clients could have different versions that are in different states. So I have to handle all the different migrations, which we did down here, where I have the upgrade that has the V3 migration. So if you were on the third version over IndexedDB, before we were storing statuses and the model you used, because when we originally shipped T3 chat, you only could use 4.0 many. So we had to add that. And I added it by migrating and setting that value automatically on things that didn't have a value set. V4, I had to do a bunch of changes. We added search. We had to generate the search tokens. All the search was local. Later on, we had to do user edited title because we allowed you to edit the titles. That's a new field. We have to default it to false so that it's always set. We also changed how statuses worked. Then I had to update some bad decisions I made about how threads work later on and do a huge backfill for that. All of this runs on the client all of the time. And all the sync logic's in here too. I don't need to harp on this forever. You get the idea. Single source of truth was a specific goal we had in mind. This ended up ruling out a ton of the options you're probably thinking I should have looked into. We'll get to those in a bit. Don't worry. Just please don't say 0 over and over again, guys. It doesn't work for this. None of this works for that. Anyways. Needed to make sure we had good optimistic updates so that when you renamed a thread, deleted a thread, sent a new message, all those things could be immediate. A huge part of why T3 chat is great is it feels incredible to use. So we had to make sure we didn't give that up in the process. I would argue that these were the essentials, but I needed more in order to justify the effort because we've already migrated so many times. So the additional benefits that I was looking for were resumable streams. So if you disconnect while a message is coming in, like if I just go to the existing T3 chat production and I send some message on a slower model, I tend to pick R1 via open router, not because open router is slow, but because R1 is slow. The distilled ones are fast, but standard R1, not fast. Write 3 poems about sync engines for databases. Now it is doing the thinking step. If I refresh, instantly is killed because that request was going to the browser from the server. My server never updates DB. The server will generate an AI response, give it to you, and then you updated the DB, which means if anything happens in that time, you lose the message. Resumable streams has been a hellish problem for a bit. And funny enough, right as we finished our changes, Vercel put out a package that kind of solves it. But that package actually is much easier for us to use now that we have migrated our own solution. We'll get to what I mean by all that in just a bit. So here we have a state users would hit a lot where if the tab falls asleep when you're waiting on a slow generation, or the easier one, and this one I would hit a lot. We're generating this. I'm going to go accidentally open the same tab in a different browser. Oh, that put us in a broken state. It just thinks it's loading. Oh no, an error occurred when I refreshed. Here, it's still waiting for the generation to happen. It's very easy to get into these states when you build your own sync engines, especially when those sync engines rely on the client to be the source of truth for everything. So I could actually even put that in the list of things I wanted. Client no longer source of truth. I'll be honest, I do not trust you guys or the browsers you use to give me the right shape of data ever at this point. I don't like clients, and I don't like the fact that all of my users being devs means they screw with things all the time. I remember when we first set up the paid tier and we restricted what models you could use. If you set a model that you didn't have access to, we would just run it with 4.0 many. And I got so many DMs and Twitter dunks of people thinking, oh, I'm getting Claude for free because I changed the name of the thing in local storage. So I went and added special code to give them a custom error saying, nice try, nerd. But like those types of things are all because I have to trust the client because the client's the one that controls the whole experience when I build it local first. I don't want that anymore. But I don't want leaving client-defined behavior to mean the client experience degrades. One more thing that is an essential for whatever we're moving to, and I found so many solutions suck at this. I'm going to put it over the line for like essentials. The other essential is that signed out experiences are good. You would be amazed how many of these solutions assume a user is signed in before anything else works. Most of them, I would say this is the case. And the final thing, I was going to put it in helpful, but I think I'm going to put it up here. Unblock my team. When you build your own sync engine, you now have to maintain your own sync engine. I know that sounds obvious because it is. But that means when you need to make changes to the data model, the sync engine has to be touched. And if your sync engine is complex, which, spoiler, all sync engines are, you now have to deal with the consequences of that. This is why things like preferences didn't sync before. This is why things like your pinned threads and this is why things like your pinned models didn't sync either. This is why a bunch of the features we want to implement are taking forever to do, because they all involve interfacing between that local store, our APIs, our chat generation endpoint, and our database for persistence. And the orchestration across all of that is kind of hellish. I accidentally created the torrent nexus for poor Mark. You get the idea. It was rough. And I still feel bad for what I put the team through. So this was one of the biggest reasons I wanted to do this. I would not migrate my database if I wasn't confident that the new solution for not just where the data is stored, but for how we think about data in our app, I had to be confident that would let me not be the one doing everything with the database going forward, because I'm too busy to be the only one who can make changes for those types of things. And I've been blocking way too much work for way too long. Problem solved, hopefully. So I was looking for a solution that covered all of this. So let's do the first one you guys are thinking. I know how this community works. Where the fuck is Zero? Zero.Rocky Corp. Cool. Zero. I really wanted this to work for us. Zero is a very interesting project. The goal, it was built by Replicache, which was like the original database sync cache layer company, with the goal of making something way simpler to set up that integrates more deeply into your application logic, that lets you keep a really good local experience where things are synced, mutations happen locally, and then get persisted to the server. And it really did seem like the solution. But it had catches. The first one, obviously, is Postgres. If you've been around for a while, you know I'm not the biggest fan. They plan to eventually do MySQL, but they're not there yet. Totally fine. The bigger catches are how you actually set it up. You obviously need to have infrastructure managing that WebSocket layer that connects to your clients and triggers the updates. They had yet to do provisioned infra, so you had to spin that all up yourself and self-host. Still not immediately opposed. Annoyed, but not opposed. Problems start to come when you realize the way the schema works. They have since changed this, I believe, because of me and a few others being annoying about it. The problem was that you had to redefine your schema in multiple places. You'd have to define it in SQL to actually get it defined, or using an ORM to generate migrations and whatnot. So you have it in SQL. You'd have to mirror that for your table definitions for the sync layer between the two. And you would have to mirror it on the client side, as well as the permission system for it, in order to make sure everyone has access to the right things and that you're getting the right data at every layer. So you write your schema. You can use their syntax for it now. I don't know if this will handle things like migrations for you now. There was some work on this, partnering with other ORMs and whatnot. I don't know what the state of it all is. At the time, it was not ready at all. You can create your schema using their new helper. That's actually really nice. A lot better than it was. Oh, cool. Yeah, you can use their migrations now from the Zero schema. That's a huge improvement. But then when you want to use it on client, you have to do a little bit more work. Their query syntax, now that they have this new proper z.query thing, is a lot better than it was when I first played with it. But once you need to access it on client, you have to deal with auth. Now you have to set up Zero with that, and you have to manually map for all the different permissions, for all the different types of data, your custom permissions functions and your custom permissions bindings in your permissions layer that now wraps that schema. This is a complex layer that requires a lot of work to set up. When I played with the first example code base with this, it was a bit of a mess. Let's take a look at Zbugs, which is their example. They have a GitHub link. Cool. Where is... Okay, it's in shared. So in shared here, we have our auth TS file. Assert user could see comment. Assert user could see issue. Assert is creator or admin. Assert is logged in. As well as the auth data schema. And we have the separate schema where all these things are defined. But none of the permissions are defined in here. Those are all now separate. Relations are defined with issue label relationships, which is a relationship from their thing. You're starting to see this. And then we have the permissions at the bottom here. Return type of defined permissions. Yeah, it's a lot. I am thankful that they have done a lot of work to solve the split brain, that this shared definition can be reused in multiple places. That was not the case before. That's a huge improvement. But it was a lot. And I was not confident that it would solve either the split brain problem or the unblock the team problem, because it seemed like it would be yet another giant pile of code to maintain. And the cool thing with Convex is if you delete the generated directory and just look at the code files I changed, I ended up with less code that's much more maintainable. So that wasn't a realistic solution. I looked into a lot of different state management solutions that had DB bindings, but I still had to deal with the multiple sources of truth between the client and the server. The split brain almost seemed inevitable, unless I was to move everything up. But if I moved everything to the server, now I have to deal with triggering updates on the fly. Now I have to deal with resumability for things myself. Now I have to deal with all the weird partial states. I have to deal with optimistically updating the UI. So I needed something that was really tied to my app. I accepted I needed an application DB. A thing that's been tough for me to accept for a bit now. So there's a huge difference between a database and an application database. I already knew this about things like analytics, where ClickHouse is a very different solution from Postgres, or BigQuery is very different from MySQL, where the priors are built to do massive amounts of data and read huge things that take multiple seconds, if not minutes, to respond. But it can just handle these huge piles like data warehouses. And obviously, data warehouses, even if they can do SQL syntax, are not a traditional DB. And I've now accepted that applications are similar too. This has catches. It means that if you're using a DB that's well optimized for applications, it's probably not going to be good at things like analytics. If we wanted to know how often things happened in our current production environment, we could query the MySQL database and get info from that. With Convex, that's a little more complex, but it solves everything I listed here. It even had a decent signed out experience piece, which most things didn't do well. The resumable streams was a problem. I guess we have to tangent a little on this problem because it's important to understand. If I generate a message on T3 chat, I'm just going to regenerate this one. Wait, no, I can't use this in Zen. This is one of the reasons I hate using Firefox for my dev stuff, because if I go to the network tab when this message is generating, we can't see the chunks coming in as they come in. They're clearly coming in. But if I was to go do this here instead in a Chrome-based browser, here we're actually seeing the streamed response as it comes in. See how fast it's updating? It's like breaking this, but you see each token as it comes in. And if I stop that, you'll see we're getting these individual rows, which are individual parts of what it is writing, broken up into tokens, which is how AI generates things. So we have, okay, comma, the user wants 3 poems about sync engines for databases, period. These are all coming through as server-sent events, individual lines in my post request response over HTTP. And I just update the UI whenever one of those comes in. My ideal would be something, My ideal world would be something like this. If we have our user, obviously users are circles, and I have my /API/chat endpoint, and this endpoint is what generates the message that the user sees. And I have the DB. What we were doing before was effectively this. User sends the request to API chat, which authenticates them, makes sure the request is valid, figures out where it needs to go, and then sends it to the LM provider. So generate message request. The server then sends down to the user the streamed response with all those individual chunks. And then I write it to the DB. So persist. The basic flow, user sends the message request to the API streams down the result, and then the user persists at the DB. So what happens if the user dies throughout? The data doesn't make it to DB, everything falls apart. So what would the ideal be? My ideal would be this. We send the stream to the DB, and the DB sends it to the user. This adds a little bit of latency at the start, but this seems like it will solve all my problems. Except for one thing. Let's look at how these same updates come through using convex. So we're going to go to beta.t3chat. Grab the same slow instance of R1. Generate 5 poems about why you should subscribe to Theo's YouTube. T3.gg on YouTube. Cool. So open the network tab. Should probably refresh before doing that. We're going to go to I thought there was a WebSocket filter option here. Is there not? I'm so sure there was a socket option. We search for sync. We have that. Cool. So now as that streams in, we're going to look at the messages we're getting. Here, we're getting these transactions, and these have a modification. The modification is a bunch of data, including the reasoning. And if we go to a different message here, you'll see modifications, type, value, the whole message still. So every time an update occurs, we're not just sending down the little bit of data that changed, we're sending the whole message. So if the message is super simple, 1, 2, 3, 4, 5, 6, 7, 8, instead of sending down, am I in the wrong thing? Yeah, I am. Cool. So if the message is something like this, we're just sending 1, 2, 3, 4, 5, 6, 7, 8. Instead of sending down 1, then sending down 2, then sending down 3, we send 1, then we send 1, 2, then we send 1, 2, 3, etc. What's even worse is I am watching the thread. So if we had a previous message, which was count to 10, then we send down count to 10, comma, 1, count to 10, comma, 1, 2, count to 10, comma, 1, 2, 3. See the problem? We send ungodly amounts of data down if we update on every token. So our options are, we can reduce how often the updates come through. Because if we are, the reason it works this way is because the sync engine isn't watching for what changed on a row. It's watching for which queries had rows change. So if we update a message, and that message is part of a thread query, it sends down the updated state of that query, which is why these systems can work at all. It makes everything significantly easier. But what it's not doing is sending down a diff on a row. It's not saying this row changed in this way. It's saying, here's the new state for the query that you requested before. So what do we do about that? The obvious solution is you update less often, or you split this up in your DB, so you're sending down individual tokens instead. But then you're storing individual tokens, and we have generated billions of tokens on T3 chat. We're not doing billions of rows. That is not viable. So instead, what you could do is you can chunk it. So instead of sending one token down every time you get one, you send down a portion of it every time you hit a threshold, maybe a new line or a timer. We send down an update every half a second. That significantly reduces the throughput of how much data is going down. But it also regresses the user experience, because if we generate something, I'm going to switch to a faster model, like 2.0 Flash. Do you see how fast it comes in? Watch what happens if I regenerate and refresh immediately. Oh no, why'd that fail? Oh, that's because I'm in the non-beta version, so it will fail when I refresh. But if I go back here, change it to 2.0 Flash, regenerate, refresh. Oh, that's a fun new bug. I'll have to fix that one later. It didn't actually change the thread that I resent that with. Cool, lesson learned. But if I'm refreshing, you see it's coming through in big chunks instead now. Instead of the individual message updates, it's coming through in chunks. If I right-click, re-roll this with Gemini, you'll see this very fast-moving one is now coming through as paragraphs, effectively. That's a regression. It's nice that we can get the updates at all when you lose your connection, but if this was the only way we did the update, we'd be fucked. So what we're doing now is this. We send the SSE response down to the user so that you can render it immediately. But if this gets killed, if you lose this connection somehow, because, I don't know, spotty internet, refreshes, you went to a different device, or maybe you're doing this as a shared chat experience with others, SSE response doesn't matter because we're sending a chunked response up to the DB that updates less granularly, but still gives you the latest state because the source of truth is always the DB. All this response is being used for is optimistically rendering the tokens when you get them. When all of this clicked, I realized that Convex could be a phenomenal solution for us because I could use it to easily update the WebSocket that keeps track of the query, to keep track of like the state of the message, the model you selected, the other threads, which threads are yours, your permissions, and all these other things could be done through Convex. And when I want the optimistic stuff or the better performance for the updates, I can just do that as a layer on top because Convex is just TypeScript. It's just written to work in React like any other library would, and it made it really easy to work with. And thanks for the proper terminology, it allows us to avoid quadratic message lengths. So what did implementing this all look like? Well, it meant I had to gut all the local storage stuff because now the DB is the source of truth. You know, the thing that our friend Uncle Bob says is evil? Now that I've done all of this, I couldn't be more certain about how wrong he is on that. DB being the source of truth makes life so much easier. All of the code is comically simpler for so many things that were really miserably tedious before. One example is how we would do title updates. When the server gets the AI message, it now has to take that thread and send it to, we use Gemini 2.0 Flash Lite to generate a title based on the content of your thread so that you get a title that's relevant to the thing that you're doing. Previously, I had to build a whole pipe to send that down as a different type of data through the SSE response so that I could take it and write it to that local store like instance in IndexedDB. And then if you had one of the cases where you refreshed and the data got corrupted, that title would never be persisted on the server at all. It was obnoxious. And it was also a ton of code, passing these serialized title chunks with certain event types from the server to the client, parsing those and then writing them properly, and then triggering the update on the server was not fun. Now, I'll just go find the actual code that does it. I'll show the legacy code first. This file particularly would make me want to die whenever I had to touch it. This is the create message file. It was 619 lines. And that Dexy file, by the way, over not quite 1,000. It got so close to hitting 1,000 lines. It was bad. So in here, I have my data parts parser on the server sent event stream. I have these different types of data that I have defined on the back end. And I try my best to make a shared event like definition layer that would be used on server and client to keep things relatively type safe. It didn't go very well. I got close, but never quite got where I wanted it to be. But here we have case thread metadata. I parse it from the content from this chunk. I log it, so if something goes wrong, I have it in the console logs. And then I would await the DXDB threads update in order to write it to Dexy, so you would see the title in the UI. But I also had to deal with all of the event management on the server side for this too, and it's part of this chaotic on data part parsing thing. It was also way worse before I found the internal function in the Vercel AI SDK that I could use on the client to parse the data, like using their responses. I hand wrote my parser originally, and it went surprisingly well considering the fact that I fucking hand wrote it. But I had 1 or 2 edge cases 2 months in that were annoying enough that I moved to their parsing, and it's been mostly fine since. Funny enough, the bugs I was trying to fix by using their parsing weren't fixed because there have been so many times where I had a bad decision I made, had a bug, fixed the bad decision and did things right, and then it didn't fix the bugs. The bug was some other layer. That happened a lot throughout this. We'll have a couple stories about that with auth in particular going forward. So this isn't even showing the server-side code. Let's find the thread metadata send on the server side. So in process request, I have my thread metadata promise. It matches generated title, so it's not an error case. Data stream, write data, write it. Then I have the thread metadata promise, results async, validate, make sure that we are generating things that we should. Generate title from user message, where I actually send the message content and the unique identifier to trigger the generation of the title. And then send this down using an async result from fucking what's it called? Never throw. Promise.resolve, the validated input, thread metadata on the else case. Otherwise, we're just returning the result of this promise. And then that has to be thrown into the data layer. Okay, thread metadata here. I'm writing this to the data stream later on in this chaotic process request function, which is also 300 line single function. Not fun. So what does this look like now? If I hop into create message. Oh, did I? How'd this get so big again? Okay, it's less than half the size. My new create message function, or my new create message file, less than half the size, significantly easier to work with, mostly passing things back and forth for the message generation. But the part we care about, create message, I get the current messages, which are almost always going to hit the cache, so this takes milliseconds, not even. I generate the new user message, generate the new assistant message where the result's going to be streamed in. Convex client mutation, this is when I generate those messages in convex, so the database has somewhere to be written to when the server starts. And then I finally call the do chat fetch request. This is the function that actually calls the /API/chat endpoint and does the generation. Fetch, method post, body, JSON stringify. On error, I will write to convex because there are some error cases that I can't write on the server. Like if I get an auth error, I can't write that to DB because if you got an auth error, where do I write it? Because I don't know you have permission to write to that message anyways. So here I write I use the set error message function I wrote, message ID, error message, error type, and auth info. It makes sure you are you. And if you are and you have permission for that message ID, I update it. This is the only place here where I, on the client side, am updating the message state during a message generation. Because certain errors I can't update on the server side. Most of them I do, though. Then we go down here. Wait, process data stream. This is the optimistic updating. I have a temp store where I send the chunked stuff. But if I just delete all of this, it will still be able to get the updates from the chunked stream. This is all just optimistic stuff. I could literally delete everything here and it's fine. But where is the title change? None of this is updating the title. How does that happen? Process request has my new caller with title gen promise. This is all the same as it was before, but there's a dot then with the title. server convex client.mutation, API internal chat update title for thread. And I pass it the new title. The client automatically gets the update. This felt magical once I wrote this code. I got to delete so much glue, all these data stream manglings and parsing and unparsings between server and client got deleted in favor of calling this one thing that just updates it in the one place it lives, which is the convex database. Being able to do this for a whole bunch of different things was such a game changer for us. We just look through the file. Update message content takes in content, reasoning, status. And I trigger a call where I update that via the mutation. Now I can chunk, and then every 500 milliseconds, I trigger an update with the new text data. And when it's done, I wait until the update that it's done. And if I get new metadata from the provider, so like things like search grounding or image gen, stuff like that, instead of having to handle all of those cases and all of the data being serialized and passed down in formats I don't know or understand, I just take it and I write it as an update to the message on the server. No more weird chaos getting data from server to client to DB. No more mangling or parsing. I take the thing where it lives, which is the server, and I write it where it should stay, which is the database. And the only reason this can work, okay, there's a couple reasons. The only reasons this can work are the sync engine that Convex provides through their WebSocket layer on top of their transaction layer. But more importantly, because my queries aren't SQL. If this was all just done through SQL, guaranteeing permissions, tracking changes, knowing what changed when and who cares would be nearly impossible. But this chat update message API is also TypeScript. It takes in arguments, has a handler, it grabs the message from DB. There isn't a message, I throw an error. There is a message and it's done. I don't update messages that are already done. I then define the update and I patch the message with the update. That's it. That's actually it. Since this is TypeScript, it's able to operate like an API. I can check that the message is from the right user. I'm effectively doing that here with the index, where I'm only selecting the message if the message ID and the user ID match. So if they don't, I can't update it. Awesome. And there's so many of these little things that have added up to an awesome experience. But the real magic of Convex is that once this fires, any query that is querying for data that this touched then gets sent an update. So we have in my side, or if I go to use thread data, this is the hook that renders the threads in the sidebar. Use session query api.threads.get, hop over here. I grab the top 200 threads. I separately grab the pin thread so I can combine them together. The thing that's magical here is that this query, after running, gets flattened into a single transaction. And now that transaction can track what data it touched. So if that data changes, it knows anyone listening to this query needs the update. It's so nice. I didn't have to write any special code to change the state of the UI or to keep things synced on DB. I just updated DB and the user had the right state. It simplifies so much stuff, and it has made maintaining this code base significantly less painful. Getting here, though, I felt a lot of pain. I basically had to rewrite all of the scariest logic in the code base while the team was still doing iteration and shipping features. The merge conflicts I suffered through are the only reason I don't feel bad about the merge conflicts I made everyone else suffer through. I literally had to spend 4 hours on a merge conflict that had conflicts in 30-something files. It was hell. But it was all worth it because this setup is significantly easier to work in. But that meant things like like certain flows that we had in the product became very different. Like the idea of a fork button. The way this worked before is I would go to local DB, or the way this worked before is I would use your local DB. I would copy all the data in your current thread. I'd make a new thread with the branch parent ID, and I would make new messages that were exact clones of the original messages. This was all local. I could do a bunch of queries back and forth, and it was fine and dandy. Now, the fork button has to behave a little differently because all that has to happen on the server. So it's one of the few things I'm not doing optimistic updates for right now, which sucks, especially if you're on a slow internet connection or an internet connection that's far away from our convex instance. Branching doesn't happen instantaneously when you click the button now because it has to wait for the server to look up all the things that are needed for the branch, create the branch, and then redirect you to it. So if I click now, it took time. Whereas on the original deployment, those types of things could be literally immediate. I'm clicking now. Effectively happens instantaneously. That sucks. And I will be able to do that optimistically. It's just a lot of somewhat painful code to write. So we'll get there when we get there. But those flows were different enough that it required a lot of work to fix. And all the different places we have things like branching or regen, all the fun features we have around it. Like at the same time, Dom was working on this awesome retry with different model flow. So to make sure that would work with the new way of generating messages and the new way of updating threads, I had to touch every single bit of glue in the entire code base to make this change. So to all of the shit posters saying, how did you screw up a database migration that bad? You should be able to do it in flight and just write the data to both places and everything should be fine and dandy. This was more of an application rewrite than a DB migration. I called it a DB migration because that's the interesting part and that's like why we were doing the rewrite, but it was effectively a rewrite of all of our most important client-side code. It was rough. I have been recording a lot less content lately because I have been no-lifing this, pulling like 10-hour days coding on this for a while. I have the PR open here. And when I was scrolling, just trying to get like the history so I could share it with you guys, I hit a very funny thing I hadn't seen in a while. 110 hidden items. This PR had like 140 plus commits. I did like 6 branches off this feature branch. It was 5,200 lines added and 3,300 removed. A lot of that was the cursor rules I added, the generated code from convex, which you should commit. It makes life a lot easier. And a couple legacy things I couldn't delete yet because I was using them for migrations. But that was all, other than like the 1,000-ish lines of like code review, but like other than the 1,000-ish lines of generated code plus cursor rules, this was all hand fucking written. I spent a lot of time going through every piece of this app, fighting everything from how attachments were persisted to how messages were branched to how threads were linked to each other. I've never been so familiar with this code base, and I built it originally. But we pulled it off. I was so pumped. Did I cover all the pieces here? We handle all the weird parts from signed out states to a very much rethought schema. Because again, I now have a schema that is just this one defined schema with a bunch of tables. I had to handle IDs in a weird way because Convex has their own ID system. But if I'm using IDs to do things like optimistic updates and link between stuff, or more importantly, I'm backfilling old ones, I need your thread IDs. So I let you define them on... Oh, sorry, my alarm for we're over time just went off. One sec. Yeah, got to wrap this one up. But we're just getting to the fun parts. Oh boy. So thread IDs are user defined because I need to be able to do things optimistically on the client. So this ID can't be treated as unique and as like a proper identifier. I have to combine it with user ID before I can rely on it for anything. And now messages have a thread ID. This is using not the actual thread._ID. This is using the user set thread ID because that's how everything linked previously, and I needed this to work for the migration. There's a lot of these things that were rough. But we figured it all out. We have this one schema that is the real source of truth for everything. My DXE file is gone. I still have an IndexedDB. Well, I still have my local DB folder because I didn't feel like moving create message and dealing with the type errors. But also some wonderfully named files here. This one for the users that had sync off. This will let me rip things from the IndexedDB instance, hopefully. But since I don't have DXE anymore, I had to roll this all myself, so it sucks. And then I have my legacy types, which is all the type definitions of what DXE previously was providing so that I can use these to migrate data over. Not fun. But once all that was settled, we had a schema that worked. We had sessions, which were locally stored identifiers for a user session that I could use in a logged out state, as well as a claim system for when you sign in to pull those over to your user instance. All the edge cases, all the weirdness, all the glue was done. Way less glue overall, but a lot of glue still, especially to glue the old state to the new model in order to get your things over. God, the fucking migration router stuff, this was fun. I have to make sure, I have to have a migration solution so when you switch over, I can pull all of the old threads from DB, all the old messages, all the old attachments, get those all in the new DB. And most importantly, I have to migrate your cookies because I need your JWT for your access token to be accessible via JS because otherwise I can't realistically get it for the WebSocket handshake. Because the WebSocket's necessarily on a different URL because it's hosted through a WebSocket service, not through my HTML generation endpoints. As such, I can't just use the cookie. And even if I could, there is not really an authorization protocol built into WebSockets, and I would have to handle that in the prefetch layer before promoting to a WebSocket. It would be a fucking mess. No one uses HTTP-only cookies for WebSockets. If they say they are, they're lying, or they're very easy to DDoS. I would encourage exploring which it is. So I have to make the cookies HTTP-only false, which led to discovering a lot of fun bugs in Brave. We'll get to all those in just a bit. But after all that is done, and we have your cookies updated so that your cookies are now set to be HTTP only false for access token, we're mostly good to go. So I then grab all of your data from PlanetScale, which is where we were storing it before. I still love PlanetScale. None of this migration is because PlanetScale bad. It's because I need a WebSocket sync engine. Attachment chunks, thread chunks, message chunks is get chunked PlanetScale data for convex. This grabs all of the data from PlanetScale. And since I need to be sure that I'm not going over the data write limits in a given invocation of a mutation on convex, I have to chunk it up so I'm not sending too much at once. Threads have limited title lengths and very little UGC, so the size of the chunks for threads is relatively large. I have 500 threads per chunk. Messages can be a lot longer, so I had to chunk those to be a smaller amount per chunk at around 100. I found this was a good balance where it usually would work for most people. Did attachment separately there. I now have this object of arrays that I can then, for each set, server convex client.mutation, migrate. I send all the chunks shaped a little differently so the endpoint can handle it properly. I do the same for messages. I do the same for threads. That writes all of your old data over, and at the end I wrap up by calling the server convex client mutation for the wrap up, which does a couple attachments for some weird relation stuff that's annoying. More importantly, it has migrated to true. So you can finally go use the app. Because the way this works, and I'll show you this in like my favorite way to do it. Beta T3 chat. I'm going to grab something quick. Cool. I have this is my database, or this is my Beta T3 chat running on Convex right now. I'm going to go to my Convex dashboard. I'm going to hide my screen for a sec. You can see this part. This is the Convex dashboard. It's actually very cool. The part we care about is data. I'm going to hide it for a sec so you guys don't see things you probably shouldn't. Now we're going to go to user config. Here is a bunch of users who have migrated. You can't see it, but it says 2,806. That means we've had 2,806 people switch to the beta and do the migration. So if I filter for user ID, and I put in my user ID, we now have has migrated true for me. I want to make this really cool because I want to show the magic. Watch what happens when I delete this row. Did you see that? Instantaneously ran. That's the magic of Convex. Your DB and your experience for your users are always in sync. It's magical. The migration ran because I have the Convex helper, Convex or onboarding. I did move it when I was overhauling some things. Hacks, Convex onboarding, core. Cool, here we are. This grabs the user config from Convex. Ignore this. This was me debugging things. I get to clean up so much of this code later. I'm really excited to do that. But I gaslit myself into thinking their cache was broken, but it was actually a very obscure thing we'll get to. User config gets an update. Use effect is triggered. If I have user data, that means you're signed in. If you haven't migrated, then I know that you should. And if you're not currently migrating, then you probably should. I have this because people were getting stuck in migration loops. But I just run it by calling do migration for user, which is a TRPC call. I also will get legacy DEXI data locally if you have sync off. I then call TRPC client migration assistant mutate. Triggers the migration. And then I'm done. It just works. And then the OK button, my most clever piece of code. When you click the OK, window location, reload. So it just refreshes to guarantee all the auth and everything is good. The problem was, if it didn't see the migration status properly, you would get stuck in an infinite loop where this would come up every time you open the page and you couldn't do anything. Okay, I want to show off one more thing that I find really fun. Let's go to this thread. Fun facts about seals. Let me hide things for a sec. Filter. Thread ID. Cool. Here is my seals thread. And here we have all this info about it. I'm editing data protection environment. Thank you for warning me. I'm going to change this to really fun facts about seals. That is so cool. It hasn't gotten old. The fact that I can just change something in DB from server, from client, from in the Convex dashboard, and the UI will always be in sync. It's magical. So where were the problems? Let me find. I shipped at 11:39 p.m., hitting my Friday deadline. Was very excited. Almost immediately started getting a bunch of replies that people were infinite looping. This is what would happen for users. They would just see migration complete over and over again. This set me into a panic. I tried to go solve it as quick as I could, handled 2 edge cases I thought could be causing it. Neither fixed it. So I panicked, reverted, and dropped this banger. So this is a mistake. People thought the mistake here is that I shipped on a Friday That was the only good decision I had made here. Okay, I made a couple others, but the shipping on a Friday night was really good because that's actually our lowest traffic point, generally speaking, in a given week. So the number of users affected was way lower than it could have been otherwise. Significantly lower than it could have been otherwise. But it was enough for me to know there was a problem, so I reverted. Everybody was really happy with the revert, surprisingly enough. And I put a ton of effort trying to reverse engineer what had happened. My conclusion was related to a specific bit of code. I'm going to check out the Convexify branch so we can see exactly how this was at that point. This was in Convex onboarding. Cool. So user info is the user info query. This is what returns when you're signed in with like your profile picture, email, ID, etc. So this is how I know you're signed in. User config is the thing I get from Convex as to whether or not you've migrated. And in the future, this will be like permission, or in the future, this will be things like preferences and whatnot. But for now, it's just, have you migrated or not? And I have this simple check. Oh, wait, ContextDB, query user config with index first, has migrated false as the fallback. So if we don't get a value from DB, I say has migrated false. What are the reasons this would come back as false when we don't want it to? Because I checked for some users and I had in DB for that user ID that they had migrated. So if I looked up a given user's user ID in our DB, it said has migrated true, but they were still seeing this because they were somehow hitting this case where has migrated was set to false, not set to undefined. It was set to false. And the user info data was set. So the user was signed in, but they were getting back has migrated false, even though the DB had them marked as has migrated true. My first conclusion is that auth must not be working properly for Convex. Remember before when I said I had to set the cookie to HTTP only false in order for Convex to have access to it? I assumed something was going wrong there. So I hit up the users that had problems, and I had them show me the tab in Chrome that shows your cookies and how long until they expire, what permissions are set, stuff like that. Most of them had the HTTP only thing set proper. A couple didn't, so I looked for edge cases causing that. I assumed that was the problem. It wasn't. I saw the expiry thing, and I learned that some of the places where I set the cookies, I had set in, what's the function called? I want to find it. User config. No, I want migration assistant. I set a max age, but I did not set expires at. And in a certain browser that begins in B and ends in rave, setting an HTTP only cookie with no expires at, even with a max age set, it will set the expires at to session. I don't know why, but it was very frustrating. So I fixed that. But at this point, I'm nervous enough about deploying this that I go out of my way to add feature flags into a whole nice fancy process for switching over to the beta, which is what you'll get now if you want to try it out. If you go to T3 chat, you go to settings, let me hide it so you don't see my email. You'll see this little thing at the bottom where you can opt in to the beta. You click it, and all this does is renders a modal with a continue to beta button that when clicked will redirect you to an endpoint that will sign your current cookies as a encrypted bundle with an expires on it. Set that as a query param to beta.t3 chat. And once you go over there, it grabs that off the endpoint, sets that as your new cookies, and then loads the page properly, which actually worked really nice. It's a surprisingly smooth migration flow. It was not fun working between two versions of the same code base and trying to pass things back and forth. There's a reason I now have T3 chat and second-T3 chat on my computer, because I had to be working in two instances of the same code base. I wouldn't wish this on most people, but it was an interesting juggling job. So I did all of this. I had people out on the beta. And all the problems with HTTP only were certainly gone at this point. The expiries seem to be gone too. I had flamed Brave enough that they were starting to solve problems, in particular WebSocket disconnection, reconnection problems that have been bugs for 6 years, finally getting fixed because of my shit posting. I am so proud. The best GIF I ever gave to Elixir wasn't speaking at their conference or helping out Jose Valim. The best gift I gave is that I raised the alarm bells on the WebSocket connection problems, and Chris McCord has been trying to do it for 6 years now for live view, because Brave users have had so many problems with live view, and now they're finally fixed. We have Keith in chat here, one of the best T3 chat fanboys, and also one of the biggest Brave fanboys, who is apparently chatting with Brendan Ike, the guy who made JavaScript, in this case, more importantly, also made Brave. They got the change out that finally handles WebSocket closes properly. It got merged. I don't know if they've deployed it yet or not, but it finally happened. Years in the making. The issue that is now closed has been open since 2021. It's been a problem for even longer. It had almost 100 comments over time, including a ton from Chris McCord. Getting more reports of this affecting Phoenix users. 2021. And the only reason this got fixed is me shitposting. And as stupid as my shitposting is, I'm not going to sit here and defend it and pretend my Twitter is some net good or whatever. It's pretty cool I can shitpost a 5-year-old bug into being fixed. And I would like to take a moment to be proud of that. So I'm going to take it. I earned it after all of this chaos. Let me have it. The number one Brave fanboy said it's actually very good. Thank you for that. So I'm taking my W. I will enjoy it. So what actually went wrong, though? Because none of that fixed the main problem. I will remind you once again what the problem was. The problem was that the user config was returning has migrated false, even though the correct thing was written in the DB. I'll give you more hints, because this is not an easy one to figure out. We go back to the migration assistant code, the code that runs on my backend that actually does this migration. The part that matters is at the bottom here, the wrap up migration, where we pass the user ID, the API key, just so I know you're not hitting this from the front end. Wrap up migration. Here we have, takes in the user ID. We look up the user config to see if it already exists. If it doesn't, we insert it. If it does, then we patch it. Then I do all that linking. None of this matters, I'll tell you that much. This all seemed innocent and fine. I'm passing the user ID over. I checked DB and the correct user ID is being persisted. I ruled out auth not being passed properly to convex, which was my biggest assumption, because it seemed like there was no way this could return has migrated false if it was in the auth state and a migration had happened. So what was left? The query cache. Most queries in convex don't actually need to read from the MySQL DB that is persisting everything. Because if it tracks every change to a given query into a given row, you don't have to care about hitting the DB, because you know if that data changed. You can just throw it in a cache and serve that whenever. Now, most requests use 0 DB at all. They just hit that blind KV cache and you're good to go. I assumed, for some reason, due to either like weird nullish coalescence or the auth info not busting the cache properly, that I was hitting this has migrated false cache instance. I was convinced this had to be the problem, because I was looking in DB, and for the user's user ID, the data was set proper. They were clearly auth because the data was like they were getting data in certain places, but they couldn't get the modal to go away because this was always coming back as false. Clearly, this has to be the cache, right? I started flaming convex for this because it seemed so obvious that was the case. until I dug into the logs very deeply. Okay, I had to add a whole bunch of logs, and then I dug into them. I could even show the updated logs. Git check out main. I had to add all of these logs because I wanted to know what was going on. I also added to convex onboarding a force no cache with random string key, where I would just add this random UUID on every request so that I knew I was never hitting a cache for that particular check. Just seemed like all the logical things. Despite all of that, one particular user, I do want to shout them out directly because they saved my fucking ass. Yeah. No, I clicked the thread. Why did it not go to it? I'm like 80% sure I just squashed the last major bug. This was when I did the random. When I added that random no cache string, that was me saying 80% sure. I was wrong, but I was able to fix as a result of this. Because Leo here, God bless him, spent a lot of time going back and forth with me, trying all my custom builds, didn't make the mistake almost everyone else made, which is when I hit them up and said, hey, can we debug this? They would say, yeah, 1 second, clearing my cookies to see if that fixes it. And that would fix it, which meant I didn't have any ability to debug with them anymore. I had 4 separate times that I hit up a user and said, please don't do anything, leave it in the broken state so we can debug it. Every single fucking time they would reload their cookies or switch browser, do something, and it could no longer repro the state. Leo was the one who did it and spent over an hour back and forth with me, sending me logs, sending me cookies, sending me everything I requested to figure out what was going on. And we figured out what it was. I'm going to show you one more piece of code because I did not see a single person come close to what the problem was. I'm not using the query helper directly from Convex when I define queries. I have my own auth query because we are using OpenAuth from the SST folks like Dax and crew because I wanted a simple, minimal JWT solution that I could fully own and control. Very happy with it overall. That all said, I had to build some custom bindings to get it working properly with Convex. Convex team made some really nice changes in order for me to have this all working. When I logged the session that I got back from Convex, when I got user through their auth helper, it had a bunch of different fields on it. One of which was the main identifier. It had auth.t3.chat, vertical bar, the actual user ID. So my original solution here to get the user ID off it is I yoinked it off it. I just took that ID, I stripped out the auth T3 chat part at the front and just used that. I got the very innocent comment, very correct seeming innocent comment. Wrong button. Hey, you should use subject because it's the proper clean ID. So if we go back to the Convexify branch, this get user function would grab it from context auth, get user identity. This gets the decrypted JWT that we have from OpenAuth. If auth info, user ID is authinfo.subject, return ID, user ID, type auth. If no session ID, I throw an error because you always need to have a session. Otherwise, I have no idea how to do anything with you. And I will give you a non-ID with the session ID if you were a non-user. This was a simple entry point to make sure everything someone does is identified. So where's the problem? I'll give you one more hint. Nothing in this code is wrong. So what was the problem? The problem was that at some point in time, the OpenAuth library, if it didn't have enough confidence in the user ID it had, it would set the auth info subject, which is the identifier that it would use, to a custom user identifier that would be something like user : whatever. I found this when I was reading through the logs in Convex for the user that was still in the bad state when they were hitting that pile of logs I showed earlier. Because I saw a user ID here that was not a format I'd ever seen before. Because up until then, our user IDs looked like this: Google : long number. It's always a number, and it starts with Google. But for some reason, there was something like this: user : I was immediately, okay, I wasn't even immediately sus because it took me a minute to even notice. I actually showed the logs to Mark, my CTO, because I was curious if he could even see the thing that was wrong. I had just been staring for so long, I figured it all out. He couldn't. No one else could see it because nobody else was deep enough in our ID system to recognize that user : is not something we've ever used. It was always Google : Turns out we had some users who had signed in the first 2 weeks of T3 chat, never re-authed since. A version bump of OpenAuth that we did fixed this case. So for every single one of our dev environments and every single person who used T3 chat starting February onwards, this problem couldn't exist. But for a very small number of users, the specific, where is it again? Let's query, gotta get back here. For a very small, very specific set of users, session was incorrect. So I had to grab this other value, properties.id, that was nested in the JWT, that was guaranteed to always be correct. But that's just a random value I'm grabbing from a key. So I have to manually cast it as a string. Now I have a user ID that will always be correct. What a fucking debugging session. This might seem unnecessarily deep. This is surface level. You guys have no idea the hell I went through over every step. I was reading Brave source code. Yeah. This was a breaking change from OpenAuth that none of us had known about that cost me 5 years of my life. When I tell you guys to not roll your own auth, I hope you fucking listen. I really do. I would have gladly paid $8,000 a month for our auth since we launched to not have had to go through all this. I am so excited to migrate to an auth provider and never deal with any of this again. You have no idea. And again, none of this is Convex's fault. None of this is, I'm not even going to blame Dax in the OpenAuth guys. It was an innocent mistake that everyone just assumed would have been resolved by now, hitting a really rare edge case I could not have fathomed. But we figured it out. The last edge case was handled. There's a couple weird things with migrating huge amounts of data that we're trying to fix for people who have like thousands upon thousands of messages. But everything's going pretty well. The one issue we have with Convex is because we have these giant messages from people's histories. And when we search indexed on the messages table, and then we're adding 50,000 rows a second consistently, their indexing collapsed for search, not their traditional like indexing for looking things up by IDs and whatnot. Their search indexing for like tokenized search, for full text search, couldn't handle the speed at which we were partial migrating. Because again, the migration is user-driven. We don't just blind migrate everything from planet scale over. I much prefer user-driven migrations because it lets us catch things as they go wrong throughout. The only issue we had there is that their search indexing wasn't used to 50,000 row chunks being added constantly with gigantic messages to index, and I'm pretty sure they already fixed it. They promised me they would very quickly. They were learning a bunch from it. The solution is we just remove the index temporarily because they know I can add it later once the migration is done and it'll be fine. Just the only edge case we hit there. Everything else has been relatively smooth. They made a bunch of changes to the convex helpers library, which has been critical for us. That library has been super helpful. The idea of sessions and whatnot's all encoded there. It's been great. I'm actually really happy with convex, which is kind of crazy to say because I was so skeptical of this product for like 5 years. I remember when it first got pitched to me in 2021. And now I don't have to worry about so many other problems I had. I feel like I have a best-in-class sync engine and database team doing all the things I had to do for my team before, better than I could have done them myself. A Slack channel of people who can answer questions all hours really well, giving us huge insights throughout, helping me unwire my old brain that thought these things had to be done very specific ways, to seeing how much simpler our architecture could be. And it is so much simpler. I am so much happier with the way things are set up. It's going to be cheaper than our current DB setup. It's going to make the experience more reliable for our users. And after a couple optimistic update changes and local storage caches, it feels just as fast for the most part. I am very happy with my move, as hellish as this has been to do. And if we go back to where we started, my list up top here, we are fully off of IndexedDB now. Everything is stored in memory. Your threads are stored in local storage, just your most recent 200, so I can load the sidebar immediately still. Split brain is gone because we just have that one, split brain is gone because we just have that one schema file that defines everything now. Optimistic updates aren't as great as I would like them to be, but they are so much better than React Query. I have a whole video about TanStackDB that's probably out by now. You should check out if you want a deeper dive on the optimistic update layer stuff. Signed out experience was really good, thanks largely in the signed out experience is really good too, thanks largely in part to the concept of sessions that they already had in Convex and the Convex helper library. My team is unblocked. I had Mark reviewing code through, and I was like, holy shit, this is so much better. I have a resumable stream solution. I'll go on one last quick tangent with that in just a sec. And my client is no longer the source of truth, the most important thing. My one last quick tangent on resumable streams. Vercel just published this package, Resumable Stream. It's a library for wrapping streams of strings like it's a library for wrapping a stream of strings like an SSE web response or AI generation, very useful for us, so that you can attach it to a Redis instance, and now you have a resumable stream with an identifier, and you can reconnect to an endpoint that will start streaming whatever you have identified that way, as long as you have the identifier to link back to it. This is great, except for the fact that I have no way to reliably get that identifier on many different clients. At least I didn't. But what I can do now, and I'm actually planning on doing this, probably not after streams, I have some shit to do, but later this week, I am very, very excited to go in here, hop over to messages, and add one last field, Zoomable Stream ID, which is an optional string, so that I don't need to update every 500 milliseconds anymore. I don't have to do all the crazy throughput I'm currently doing. Instead, the stream will come through Redis where it should be. And Convex just tells me where to go. It's funny how in the end, the solution I was about to build, which is resumable streams via writing to Redis with a restoration layer that I would build myself, possibly even spinning up durable objects and a bunch of chaos there. I had mapped out the whole thing in my head, decided we had bigger fish to fry, went the Convex route instead. And now that the Convex route is done, it all clicked in my head, and I could literally, in 10 lines of code, have tokenized resumable streams once again, with everything handled. Oh man. What a journey this has been. If I was to start from scratch, I would have started from scratch on Convex. My lesson has been learned. My brain has been rewired. I am significantly happier. And I am so happy to be done with IndexedDB. If you're ready for yet another hours-long ramble about all the things I hate, keep an eye out for that local storage exit video where I explain all the reasons why I gave up on local retake on that last bit. If you enjoy long-winded rambles about my chaos like this one, hopefully you understand, or you like the long-winded ramble that you just experienced, you're probably going to love the longer one about why I gave up on local first development. That's coming soon. Going to go much more in detail on all of the parts that made me exit over here in the first place. But I wanted to focus today on the thing that I did and why I did it, not the pain I felt to do it in the first place. Thank you for listening. Give Convex a shot. They did not pay me a cent for any of this. In fact, they're probably going to cost me a whole bunch of money going forward. But I am very happy I made the move, and I am begging them to let me write a check to invest because I've seen the light. This is so much easier to deal with now. Or this is so much easier to deal with, and I'm very happy. Don't migrate your database 4 times. And if you do it on Fridays. That part wasn't a big deal. Let me know what you think. And until next time, be very careful with your data. Okay, one last thing, I saw it in chat. This doesn't need to be in the video, but Dev, seeing my position change on Clerk and Convex has been so validating. How validating has it been to see my perspective change on local first, though? Because I flipped from being slightly reserved but excited about it to thinking it is a scourge that should be avoided at all fucking costs. Now when somebody says local first, I write off their quality of software and their quality as an engineer because it is so fucking bad. It is unforgivable. That video is going to be so heated. You guys have no idea. I'm going to go fucking insane. I'm wrapping this one up. Yeah, we literally talked about databases for the entire stream. Was not the plan for today. Thank you, Owen, for joining as a member over on YouTube. Appreciate that. Don't get a whole lot of the financial support over there. Always cool to see when it happens. Let me thank all the subs that I missed while I was going. Then I have to leave. I'm already 40 minutes late. I missed a ton of y'all. Jesus. I definitely got Kevin. Sterling, I'm pretty sure I got you. Regardless, appreciate it. And then Jam out here, CEO of Convex, coming in with the gift bomb and subbing himself. Appreciate that a ton. Emily, 30 days left till the 1 year mark. I feel like you've been around for way longer than that, but appreciate it a ton. Thank you as always for the tier 3 club. William here with the Prime, 5 months in. Appreciate that. Spec here, 22 months in, almost at that 2 year. Ian, 15 months in. Thank you for the support. Taco Bandit, 15 months in as well. CJE, 35 months in, almost 3 years. It's gonna be one of my best videos. That was the neon one, so I hope so. I was proud of that one. RemXB4, 12 months in. Appreciate that. Fallaway, 4 months in. TWT, 6 months. Signing up mid-ad doesn't help the ad. Yeah, it's annoying. Sorry about that. I couldn't fix it when I was at Twitch. It's too late now. Speaking of Twitch, Userin, old friend from Twitch, almost at the 3 year mark. One of the OG supporters. HD with the 10 bomb, right when we started filming that one. Appreciate that a ton still too. Gamer Girl, always good to see you. Thanks for the support. Jabba with the 10 months, 2 year or a year total. Thank you for that. Blazingly Slow throwing the 10 bomb. HD Negative throwing another 5. Sebastian, always good to see you, man. Jump scared by the bathrobe rant. Thank you. I've been sitting on that bathrobe for a minute to do that. I just needed the right thing in time. Happy I did it. Charka here with the Prime. Reese, 27 months in. Fucking legend. Good seeing you yesterday, man. Wait, no, I didn't see you yesterday. Wait, did I see you yesterday? Yeah, I did. Yeah. I'm trying to remember who were the people I expected to see that I didn't see yesterday, but you were definitely at the thing. Then Demi here with the Prime. Dev here, the 19 months. 2023 was Theo plus Clark. 2025 is Theo plus Convex. What's next? Theo plus Solid. Had a lot of fun talks about Solid yesterday, funny enough. Malik here with the tier 1. Pleb here with the 9 months of support. Jiraj here with the 33 months of tier 3. Fucking legend. Artem throwing the cheer. Malik, Got your name right. Thank you for the 25 bomb to wrap us up. That is huge. Thank you all so much for the support. Goes way further than you know. I don't expect Payload to support convex. They're very different products. Yeah, this was an awesome stream. Happy we got all of this done. What a wild set of rides this was. I need to get out of here, guys. I'm so late. If you have somebody I should raid, let me know. I'm going to quickly try and find somebody. Is there anybody that I owe a raid to? T-Pain feels fun. Yeah, we got to raid T-Pain. Have fun with T-Pain. There's an on Clerk that I like Clark. Oh shit, did I miss Polymars was live? Fuck. I already committed to the T-Pain, but we'll raid Polymars in the future for sure. Goodbye, nerds. I might see you this weekend because I'm very behind on videos. I can't. I have to go. I'm already so late. Sorry. Bye. Goodbye, YouTube as well.